I think it's live, maybe. Let me know if you can see me, because I just have an error on the YouTube studio. Hopefully this is okay. Maybe we're working. Okay, great. Fantastic. Thank you. Oh my gosh, it's been so long. I haven't streamed for 18 months, so I feel like I'm bigging this up in my head way more than it needs to be. I'm actually dead nervous. So, yeah. I have a bit of a plan for today. I don't know if you saw, I did like a tweet was it last week? Where it was making this like metaball thing, which it's actually like, it's pretty responsive. It's all geometry node stuff. But yes, should be fairly straightforward for us to build it. And I was surprised that people were actually that interested in it, because it's just metaballs, really. So there's yeah, I didn't realize it was like a thing that people actually wanted. So here we are, we're doing a live stream about building it, and we're going to be extending it to cover arbitrary meshes. So it'll do like mesh to SDF stuff as well. Hey, from Brazil, amazing. Meta what now? So metaballs, if I just show ya. Ooh, apparently I've got poor stream status. Hang on, let me know, just shout. Oh, we're lagging. Okay. Bear with. There's going to be a little bit of like working out how to get everything running smoothly. It's been so long since I've done anything with the internet, so I actually might just be able to change to I have like 2 broadbands, so I can just pick a different one. But yeah, let me know if it's catching up again. Hopefully OBS says that it's streaming like 5 meg. So that should be more than, like, it shouldn't be dropping any frames. So maybe it's on the YouTube side. Okay, let me switch internet and we'll see if that clears things up. Are we pushing data? I shouldn't be streaming it. No, it's 30. Yeah, it's just 30. OBS is reporting that it's transferring okay though. So I'm not sure what's going on with the YouTube side of things. Technical difficulties, isn't it? This is always the way when you're doing, like, I love that we're all tech artists and supposedly really know how to use computers. And then as soon as you try and do something like this, it's like everything breaking. Okay, let me know if that's any clearer, because sound continues. I wonder if I should just drop the quality a little bit. Let me try that. Maybe. So I've just dropped it from 5K to 3.5K, which is pretty poor. But hopefully you'll be able to see it. And if I don't move the screen too much, it shouldn't like get too choppy. Yeah, I feel like I'm going to need to move things for you to actually see if things like it. Yeah, just let me know if this is like smoothed things out a little bit. YouTube Studio is still complaining. OBS is all green though. So, okay, thank you, great. Okay, so let me jump straight back in. A metaball in Blender is one of these weird objects, and we've got planes, like supposedly planes, it's like a rectangle. And we've got ellipsoids and cubes and balls, and the idea of them is that you have, how is my cursor so giant? Windows settings, you just make it massive, and then then you can record it. It's useful if you're on phone and you're like, you have a tiny screen. It's often easy for me to forget that people have small screens because I have like a larger one. But the idea of metaballs is that you can create this kind of homogeneous mesh, and it's like one continuous surface. Like if you look inside, it's just the outer hull. Although it's actually getting remeshed, so you can see a double one there, because it's inside my metaball empty collection. There we go. Oh, no quality drop. Great, thank you. That is good to know. Actually, if I can just stream at 3500, that is very lightweight. The problem with metaballs is, well, there's so many problems with metaballs actually, and I think this is why many people don't use them. Like there was a really good Blender conference talk on metaballs, animating with metaballs by, oh, what's his name? Begins with Z. But he did a really cool animation using metaballs, but you have a lot of limitations. And essentially, that you can set your resolution in here under your settings, and you can choose, if I can remember how to do this, whether a metaball is adding. I can't remember how to do it, but you can choose whether, yeah, Zugermaster, yeah, thank you. You can choose whether a metaball is going to add or remove, like an SDF, like doing a Boolean intersection or a Boolean difference. We want to have similar kind of control system, but with metaballs, you can't do different colors, you can't do different materials. There's nothing that's really generated, but here in our mesh, we've actually got all of the color data coming through. We're generating it inside geometry nodes. And alongside this, we're also storing masks. So if what have we called it? So like if I go 3_mask, then you can see that I've actually created this SDF of that surface. So, and it's smooth as well. So it's not geometry dependent so much. And then you can do stuff in your shader, which is pixel based, to actually turn this into a usable mask for one specific part of your model. So this is a really powerful way of working. And if we can extend this to do arbitrary meshes, so you could actually model something and drop it in, or if you wanted to have something like, I'm trying to think of an example here. So like spline workflows, you could throw a spline in there and just have like an SDF of your spline. You could have, you could create characters, you could pin, like if you could do armatures, and then you could hook empties onto it, and then we could use the empties in the geometry node. So you could animate, you could have a fully animated rig live generating this SDF output. And because we've got all of our masks, we can still then apply materials appropriately. And all of our masks are generated here, right? With this value to string. So the name of this is being generated procedurally, which means that we have as many masks as we need, right? Because this is running inside a loop. So if you want to generate 100 of these objects, let's go back to our main material. You can see if I take one of my empties and I duplicate it, we get another ball and it has its own color. And this is just growing as many as we have. What is the conference video name? That is a good question. Let me do a quick Google for you. Is it going to be under Zugermaster? It was going to be like Metaball at Beacon. Was it Beacon 20? I feel like, because it was pre-COVID, wasn't it? Or maybe the last one before COVID. Would that have been 19? Yeah, maybe it was called Metaballism. I feel like that might have been it, because there's a part 2 here by Alex. So yeah, go check that out. You can do some crazy stuff as soon as you have SDFs available to you, and because we're working with geometry nodes, then you can take that even further. So you can if you've ever seen people doing like, have you seen like PlayStation Dreams, which is like a VR game, but that's modeling with SDFs inside a PlayStation, which is crazy. But the worlds that people create in there are just incredible because you have so much freedom. You're not constrained by topology. Yeah, just like all of these conventions that we're used to as 3D artists. If you can work in a way with SDFs, there's going to be a little bit of like triangulation and whatever so that your GPU can render it. But in terms of you actually building something, you have a huge amount of freedom because you're just working with space. Right, so let's jump in and actually start building something. Also, if anybody has any questions or if you want advice on your own projects or anything like that, you can just jump in the chat and I am very happy to take a tangent and have a look at anything else. There's no time limit on this stream, so we can bash out whatever. Okay, so first thing we're going to need, we're going to just build like the basic version, which is going to be distance from points. Oh yeah, conjure SDF. Yeah, so Charon just brought up a point about an add-on being developed by John Kaz, I want to say. Incredible. Actually, I've got to show you this now. It's so cool, but it's, so I've never used it, so take my words with a pinch of salt here. I don't know if it's fully integrated with Blender in a way that you can actually like use it through geometry nodes or add custom meshes and things like that. So even though there are other, I'm not going to be able to find him now. But yeah, conjure SDF. What we want to have is a way that you can have this deeply procedural system that works natively inside Blender. There's going to be limitations, but it's geometry nodes, so you have also complete freedom to do what you want with it. So if we just start out here with a new collection that we're going to call empties, and we're going to just throw in a bunch of sphere empties, and I may make some of these different sizes as well, just so that we have a difference in there. I think CG Matter also did a video on SDFs last week, which is really interesting. He built like a custom render engine inside a shader so that it's like ray marching SDFs, which is always super fun. We were doing that, I want to say November 2020. Yeah, loads of us were doing like these insane vector displacement and ray marching setups in shaders. And yeah, if you're interested in how that stuff works, go check out CG Matter. Hey, how's it going? Go check out his video because it goes so in depth and it's just super interesting. So I'm going to add another collection here, which is just going to be our actual geometry nodes object. This is something which I feel like is a workflow thing that a lot of people don't do. Like a lot of you probably, if you're doing something with geometry nodes, you'll make your object that is going to be the geometry nodes, even if it's a mesh that you're using, and then you will put geometry nodes on it, and then you will use your geometry input geometry to do stuff inside that node graph. I actually would say don't do that. Always have your geometry nodes, unless it's a very small thing you're doing with geometry nodes, but if you're building a larger system, put your geometry nodes on a different object, because that is going to give you the freedom to pull in your various states of geometry. And if you need it in a different geometry nodes graph, then you still have the unmodified version versus the version that's going through a geometry nodes modifier. So it just gives you a little bit more agility to work with there. So I've got my plane. I'm going to call this one metaballs or betaballs. There we go. And new geometry nodes. And we want to pull in our empties collection. So first things first. Well, let's just break this down into a fairly simple situation where we're basically just taking the distance from the empties. And that's going to show you a bit of a limitation here. And then we're going to pull it apart with a repeat zone that we are, yes. Actually, in this case, we are using the repeat zone correctly. So I'm sorry if I'm talking in abstracts as well. I'm just like, brains going. The title sounds like clickbait to certain type of people. Yeah, no, we're actually building metaballs properly. So let's take our empties collection here. And very simply, let's plug this through a geometry proximity. This feels so small. Has anybody been using 4.2? I feel like the geometry proximity, sample nearest surface, those nodes have all got a bit of a punch up for 4.2, and I'm hoping they're going to stay like this. But if I add geoproximity up here, so in 4.2 you can see we've got group IDs and sample group IDs, so you can just like actually use the data in a way where you're curating who it's coming from and where it's going to, which is huge. Also getting the is valid output, also really big. Yeah, I was literally using this yesterday, like, oh my god, I've been needing this. CG Hiker, is this video going to be available later on? Absolutely. This is going to be just, yeah, available on demand afterwards. It's just recorded as a regular video on YouTube, so you can go and watch it. White Devil came for meatballs. I'm sorry to disappoint. So we've got a geometry proximity on our empties. We have empties. If I just hide the actual empty collection. Don't reset those children, actually. We need them on their original locations, and we can't use instances because they're not geometry. Sorry, we can't use empties because they're not geometry. So if I was to realize instances, this is not going to work, but we can do an instance to points, and then we're going to get a point where each of our empties is. So that's how we're going to do this. Geometry proximity from points. Then we're going to use a volume cube, not point to volume, because we want to have control over our density field here. Take our distance through a subtract. This is a standard way to add radius to SDFs. Into that density, I'm going to set my background to 1, because the value that we're interested in for the surface is going to be 0. So we're going to basically, it's called an iso surface, where you have a mathematical surface defined, and the most convenient way of working with that is at a value of 0. So 0 distance from the surface. We're going to take our volume cube through a volume to mesh node, threshold of 0, that's what I was just saying, and then we can plug that onto the output here. Now nothing's showing up because our min-max is probably too small, so let's also take our instance to points output through a bounding box node, and we'll just plug the min and the max through there. Great. So the groups are an integer type. Yeah. So basically, if you think about an index of just geometry, you've got like 0, 1, 2, 3, 4, 5, etc. per geometry element. That's essentially a grouping per element. It's just that each element is within its own group. It's a self-identified group. If you have something like, let's say you're doing a duplicate elements node, you have this duplicate output, and this is going to be an integer per duplicate. So if you were to take a box and you were to duplicate it 5 times, then you would have boxes 0, 1, 2, 3, 4. Yes, 4. So that's going to be basically a group ID per grouping, and it's just an easy way for you to assign integer values. It's on the accumulate field node. Hopefully, I don't know if we're actually going to get this at any point, but I'm hoping that we'll get it on the statistic node, because that would be very useful. But yes, it was already possible to do metaballs with 3D Studio. Oh, that's going back a little way. I think that was actually before my time. If we take our volume to mesh, you can see that these are all red. That's my face orientation. So let's do a flip faces on here. Okay. Now, each of our instances has a scale because our empties are different sizes. And so it would be cool if we could define, actually, we'll come to that later. we'll come to that later. So let me just show you something now. If I move these empties closer together, such that we get a join, and let me increase the resolution here as well, so I'll just set this to maybe 256. If I move these together, you can see that we're getting a sharp valley in the middle of here, and I want to be able to set some kind of smoothing, but smoothing is going to require us to use a different function. So right now, geometry proximity is basically calculating the minimum distance to the nearest point. So whichever point is nearest, you're just going to basically find out what the distance to that point is. We want to use, rather than the minimum from all of them, the smooth minimum. And this way we're going to have a smoothing distance. And let's demonstrate this with 2 points. So if I take 2 points, geometry proximity each of them, and let's set this to minimum, you'll see that this is going to be basically the same as what we have. And we'll go through our subtract as well. Let's move one of these to one side and one to the other side. And you can see it's exactly the same. We just have that sharpness, sharp valley. And then let's take our smooth minimum instead. And now you can see that we have this distance function, which enables us to basically smooth in between them. It's kind of like a blur attribute. Well, I say that very loosely. It's very loosely like a blur. But yes, you can join them that way. Okay, so then we have another problem. We can only use smooth minimum when we have a distance function being compared against another distance function, which is therefore going to require us to have different points. Right now we just have one collection of empties, and I want this to grow as much as we need it to, based on however much geometry we feed it. So we can't just give it, let's say 4. When they are joined, do they still have interior faces? No, that's the great thing about SDFs. So SDFs will only draw, I don't know if that's clear in the video, but they will only draw faces where the value is, in this case, 0 on our mathematical function. So it's not like two things could ever intersect, because at some point the surface is going to be at a different value because you're closer to another point. So you're going to basically, you're only ever going to create one continuous manifold surface, which is why SDFs are so nice for working on things, because you get the minimum, supposedly the minimum surface area required to define a shape. The difficulty is in how you triangulate it and turn that into a mesh which is actually usable, especially if you want to work in video games or something like that. But that's kind of a different problem. Okay, so that is the problem space. We're going to be taking, what's going on? We're going to be taking the geometry that we've made, and we're going to be splitting it apart with a repeat zone, and we're going to be finding the distance per loop, so we can define various values per object that way, for example the radius, and then we're going to join that into this larger distance function, and we're going to just loop over each one of our empties until we have a full complement of SDFs. In theory, it should be quite straightforward, but I feel like this one was an absolute brain twister for me. I think people think I find geometry nodes easy, and I really don't. I think the thing that I enjoy about it is that I find it very confusing and therefore very gratifying to do properly. So collection info, we're going to be taking I'm going to keep all of this information here, but let's bring our subtract instance to points. Bounding box can come afterwards as well. So utilities, repeat zone. What do I think about EV next? I've not used it very much, but I was using it a little bit yesterday, and I thought actually so many of the things which I don't like about EV are sorting themselves out with a little bit of raycasting, like raycast reflections, raycast refraction, just like little bits like that. It's just such a nice quality of life to not have to do all of these. So this is the thing that I think with a lot of rendering. Things like using Unity, Unreal Engine, actually less so Unreal Engine 5, Godot, like any of these things, which is, they rely on you knowing how it renders. You can't just hit render and hope for a good result, kind of like you can with a ray tracer like Cycles, because with a ray tracer, it's going to behave predictably. It's just like shining lights on stuff and then it sort of works. As soon as you have are they called raster render engines? Things like Eevee and Unreal, like those real-time ones, they're just, you got to know things about irradiance probes and baked lighting and all of these things to be able to create good results. So you have to know a lot more very esoteric knowledge, which I'm not really a fan of in terms of usability or artistry, because you as a creator, you just want to make an image. You don't want to know, like I don't want to have to compile Blender to run Blender, if that makes sense. But I feel when I'm using something like Eevee or Unity, like I'm having to compile a system of lighting rather than just add lights and it works. So I'm optimistic about Eevee Next because I think it's going to alleviate quite a lot of those problems, quite a lot of those like user problems that I find with it. That is just my thoughts though. Obviously, if you're familiar with that kind of render engine, then like I've seen people doing incredible work. Have you seen Gleb's video series on is it photographic or cinematic lighting course he did? Absolutely incredible. Just incredible. It's such beautiful work. And yeah, that was using Eevee for a lot of those sessions, which is incredible. All right. So I want to make sure I'm explaining what I'm doing here because this repeat zone stuff gets a bit confusing. So let me just let's take out this instance on point stuff. We'll add it one by one. So we've got a repeat zone, and if I use a viewer on the inside, if you go to the node settings up here with the repeat zone selected, you have this inspection index, and this is choosing which iteration it's going to show you when you do a viewer. The number of times we're going to be doing our repeat is based on the number of empties we have. So let's use a domain size node, set to instances, and the instance count is our iteration count. There we go, fairly straightforward. More repeat sounds. I think this is the first time I've ever used a repeat zone the way that repeat zones ought to be used, which is to say as a serial loop, like one after the other, after the other, after the other. Whenever I've used them in other projects, I've pretended they're for each zones. So I just really hope that we get a for each zone at some point, because it doesn't seem to me logically like it would be very challenging from like a design point of view. I don't know how you would code it, but yeah, having that parallel processing would certainly speed things up. So inside the repeat, we are going to need to split one empty per iteration. So let's come in here. We're going to add to our repeat zone a new one called loop index, which is an integer. And I'll drop that to the top. And we need to make sure that each loop, this integer, is incremented by 1. So we're just going to add a value of 1, right? So simply take your loop index, which is going to start at 0, and each loop, we just add 1 to it and pass out the new loop index for the next loop. So I'm going to rename this node to +1. And now we can take our geometry, and let me rename this as well. It's good to be explicit. So this is going to be our empties. We're going to take this and we will separate geometry, instances. Let's have a look at our selection. And we're going to be doing it where the index is equal to the loop index. So let me hide that empties collection. So we can just see that we've got one empty coming out at the moment. And if I inspect a different iteration, then you can see that we're pulling up a different empty for each one. So each loop is looking now at a different empty. It's important that all of your empties are ferried through the whole repeat zone, and anything that we do and pass out would then come into a new socket. So this is just because each subsequent loop needs access to all of the empties to know which one it's pulling out. Is there a different way of doing this? You could do this without the loop index, just by maybe passing out the inverted one and always pulling off the first. That would be maybe another way of doing it. In fact, would that work? Let me try this. I feel like I always go on tangents with these things, but so if I were to have 0 here, oh, that actually would work. I feel like it's less explicit and therefore I don't trust it so much. I like to see a lot of what I'm doing, like very explicitly. So I'm going to keep it set up like this just because I feel like that's a more useful paradigm for you to learn. PZQ, hello, how do you find, or do you find geometry nodes is pretty on the low level, like in programming languages? Mixed, I would say, because we do have access to basic geometry and we can use the mesh topology nodes to do things like, you know, walking around the faces belonging to a corner or the corners belonging to a face, and then you might select the vertex of that corner and then you might select an edge from that. Like you can walk around geometry, especially with repeat zones, in a way which is very useful and efficient. It's not quite low level enough in terms of having access to arrays of vertices and being able to modify lists and things like that. At least I would say I think that. But you can do a lot of crazy things if you know how to hack and take advantage of geometry nodes. Like I saw there was something on Discord, was it yesterday? I think Quackers was doing it, where they were using like 3 accumulate field nodes to do some crazy geometry, like topology understanding, like walking around something. Sorry if I'm not explaining that in any way correctly. But if you understand about grouping, like let's say for a certain group you are going to be using like a, so if, let me just explain this properly. Let's add a grid. If I view my grid and I view the trailing value while I have a value of 1 in my accumulate field, and an accumulate field is a sum loop, so it will add whatever is in your value every frame or every mesh element. In this case, we're using the point domain. So you can see in our outliner, just show the thing from Discord. I would show the thing from Discord if the, do I even have Discord open? Bear with me. It should be in, I think it was in general. If people are not on the Discord, by the way, it's a really good resource for everything geometry nodes. So you can just go into the Discord and you can just search for like anything that you're after. And it's great because there's so many things in here. Like people were talking about camera culling in shaders using OSL. And it was just super interesting. Like I've never come across that stuff before, and yet it was just straight up in the chat. Oh yeah, here it is. Yeah. So this Quackers. So this is a sort group ID node group. Hey Duncan, how's it going, man? So in this group, what they're doing is they have a group ID. They're incrementing by a value of 1. They're using this trailing value and they're using that in the delete. So what it's doing is it's deleting every point which is not the first point within a group. They're then setting the position to the X value of based on the group ID, and that's going to separate things out into their group IDs positionally in space, and then sampling the nearest and doing the evaluate. So this is one of the ways that we used to do a lot of stuff, was basically using position as a dictionary. So you could look stuff up, you could position stuff based on some values, position other things on the same values, sample data from one to the other, and then reposition back to the original positions. And actually, if you follow my old bounding box tutorials, that's how I did a lot of stuff. Now, this doesn't do any sampling, so it's much, much faster. And they are doing the same group ID as the accumulate, and then they're accumulating using that value as the new group ID. So now the first or the 0th value, for example, within each group is set collectively into a one new group, and then you can do data management manipulation with that to find out data. So it's just crazy how much you can do if you know a little bit of the specifics of how geometry nodes works. But yeah, is geometry nodes low level enough? Probably not, especially because we don't have any real method of what's the word? For like procedural modeling workflows, I wanted to say something specific, but I can't. Like tessellation. So there's no convenient way of doing mesh replacement. There's no convenient way of doing procedural mesh manipulation, like bridging edge loops or things like that. And that's a shame, because it means that we have access to a lot of scattering tools, which was what geometry nodes was originally for, right? Scattering pebbles. But actually now we want to have a huge amount more, like we want to replace a lot of our workflows with geometry nodes. And it's building towards that, I think. And over the next, I would say 3 years, like if you're not a fan of geometry nodes how it is right now, I would say still learn it, because you're going to get the easy version to learn right now versus in a few years time. But I would say 2026, 2027, maybe even like, yeah, I don't know, like Blender for 2030 is going to be just so different. It's going to be crazy. There's going to be so much more procedural emphasis on the workflows, and so much more node-based stuff. So I'm optimistic for the future of Blender. For procedural modeling, we are missing 3D viewport interaction with selection sets, bevel, and remeshing. Absolutely, yeah, Patrick, that is so true. Gizmos, there is a branch for gizmos which you can have a look at, and I think that's going to be in kind of the next list of things which gets discussed. Yeah, I think because 3D viewport stuff, even just for like if you add a transform node, you want to have like a 3D gizmo pop up. I remember back a couple of years ago when I was doing the Mouse House streams, one of my biggest problems was actually getting things positioned, because I was working at quite a small scale and I was moving things like 1 millimeter at a time, and it was almost impossible for me to actually manipulate things appropriately and get things going where I wanted. Lil Key, is it possible to do metaballs with mesh as well, or is it just for empties? It is for everything. The current version that I've built is just for empties, the one that I put on Twitter, but we're going to be extending this one today in this session to do arbitrary meshes as well. And that will essentially be having whatever we build here, we will do an arbitrary mesh version below, and then we will simply join these two distance functions together. And that should, hopefully, I've not tested it, so it's going to be a bit raw today, but it should hopefully give us a bit of a look into how this is going to extend, and then you can extend it to curves or whatever else you want to do as well. Okay, where are we up to? So we've separated one object per loop, and then we're going to take our instance to points to give ourselves a point, our proximity node from the points to give ourselves that distance function, and then we also want to set the radius of this distance function. So if I was to just plug this out directly through our repeat output, and then this needs to come into our volume cube, and let's just make this like -10 to +10, just so that we can see something. So we've got our distance function. Let's subtract some value from it, and there you go. Now you can see that we've got you've got some value coming out. White Devil, what is the advantage of betaballs versus the metaballs? Materials is the main one. Well, partly materials and partly if we succeed in getting arbitrary meshes in. The standard metaballs either can't do material differentiation per thing, or it's very difficult and I've not learned how. What we're going to be procedurally doing is generating a random value per betaball, per like SDF section, as well as creating procedural masks that we can then use within shaders. So let's say you're making something hard surface and complicated like a gun. You might subtract a bunch of stuff and how are we going to do subtractions actually? That's going to be interesting. Either way, okay, I need to make a note of that and then come back to it later. But yes, if you're adding a bunch of stuff, like you might want to have different materials across different parts of your hard surface model. If you have screws, maybe they want to be a paler shade, things like that. Like we want to have something which gives you a lot more variation and artist control of the final results. Is betaballs the same as Conjure SDF? It's not. Conjure SDF is a custom SDF modeling tool with a custom OpenGL rendering setup, it's really fast, Conjure SDF, because they're not triangulating with like the B-mesh stuff within Blender. They have written their own SDF interpreter that runs on top. Sorry if I'm lagging. I just got another error on YouTube. OBS still seems fine. But yeah, so my understanding of the Conjure stuff is that you can't do things like custom meshes. That this all might have changed as well, so don't take my word for it. And also like geometry nodes stuff, partly because it's not triangulating, and partly because, well, I don't know. It's just that what I'm building today is similar. Fundamentally, we're doing SDF workflows, which are very flexible. So, okay, so this is our radius, this subtract, right? We can set our radius however we want here, but our radius should actually be the scale of our empty, right? So there it is. Whatever our empty is scaled to here wants to be read as the radius. Do we have access to this anywhere? I think we should do. Position. The radius here is set by this radius. So what we want to do is probably capture, or maybe we could just do a statistic. That's probably the easiest here. So let's use an attribute statistic node on the instance. So we were interested in the instance domain. We are interested in the instance scale. Now I know this is a vector going into a float. I'm just trying to think if there's any reason we would actually want to use this as a vector scale. Maybe this can just be a limitation, and if we want to do more complicated mesh based or like mesh style operations, then we can just do it on the meshes instead of empties. And then we'll just take the minimum value. Right, and this is a value of 1 apparently. Oh right, yeah, because it's the first one, sorry. Yeah, okay. Let me make that a little bit bigger and just check that that's working. Yeah, so 1.9, that's good. So I'm just using the statistic node just because we've separated off only one of these anyway. So there we go. Now we can take this minimum and we will just use that as a subtraction. And now you can see that our mesh surface is very closely now tied to our empty. You can see it breaks away there, but that's just because of our sampling resolution on the volume cube. Yeah. I know a couple of designers that hit a brick wall trying to learn subdiv topology. I can understand why. It's one of these things, you know what I was saying before about not liking Eevee, because you have to know stuff, you have to know specific stuff about lighting setups and things like that. Topology is the same problem to me, I think. There's so many things inside 3D which we do naturally. I've been using Blender for 15 years. Many people here have been using it for longer. And we're so familiar, and like any of us who've been doing mesh modeling anywhere in any software, we're so familiar with, you know, like edge loops and how do you terminate poles and how do you move a pole around somebody's face and things like that. That kind of information is not intuitive, and it's not easy for people to learn. So yeah, especially if you're coming from like 2D vector graphics and you're like, oh, I just want to put stuff together and do like a union intersection here. Yeah, having SDFs is basically what you need, because vector graphics is basically SDFs. So there we go. Will the future volume nodes help with SDFs? There's already some volume stuff, isn't there? Is it in 4.1? No. We've got mesh to volume actually. So this is not an SDF. I feel like I've seen a mesh to SDF node. I might be wrong about that. It's not in here, is it? If I search SDF, mesh to SDF. Oh, that's one of my notes. Yes, I expect that when we get better volume support, we will be able to do things like adding two volumes together, interpolating between volumes, smooth interpolation between volumes, which is essentially what we're going to be doing today. Right. So we've got our basic distance function, we've got our radiuses working. How do we actually join this to our other ones? Because as you can see, we've only got the final empty working, and it's actually really simple. So with a repeat zone, they removed the SDF volume nodes in experimental, did they? Is it even in Blender 4.2 or 4.3 they will have had? Oh, I wonder if it's just one of those things. I always get confused when I'm going from like alpha builds to stable builds. Is SDF in here? Experimental. Yeah, when you're in alpha builds, there's loads of experimental stuff. It's got matrix sockets. Yeah, it's not there, is it? Interesting. Oh, okay, that makes sense actually if they're getting scrapped. Hey Marcel, how's it going? Did a mesh to SDF node group for a cave generator project of mine. It's probably very similar. I would hazard a guess that you're using raycasting, and that's what I'll be using as well. So we're working in a repeat zone. We want to grab our distances from the previous loop and join them. Very simply, take your distance from the previous loop. We're going to be taking this through a minimum. Actually, it will be a smooth minimum. There it is. And plugging that into distance there. Okay, this looks absolutely terrible. This is because our distance here is 0. So if you think about our distances, the surface we want at a value of 0, and every time we're going to be adding a minimum distance. And basically we want, Andrew, does this method support motion blur vector paths? That is a very interesting question. We can test it actually. Just before I do, sorry, let me just finish this thought. So we basically want our distance from our default 0th value distance to be not 0, because 0 is the value we're looking at. So if we set this to something large like 100 or even bigger, like, yeah, let's go 10,000. So it's just a massive number. That is going to basically guarantee that we're always going to be looking at the smooth minimum values, which should be around 0. So now we can set our distance in here, and you can see these are actually joining together, and we have all of our data, and it looks beautiful. Isn't that nice? Okay, before I carry on, let's have a look at this vector pass motion blur stuff, because I feel like it should be, where are we at? There you are. Okay. If I just animate one of my empties. So let's do that, and let's do another one up here. That's too slow. Okay. So I would expect some motion blur, I guess, on that. You don't use raycasting at... Ah, right, okay. Interesting. I've never used mesh to SDF inside a repeat zone, so we will see if I have to come up with a different solution here. Let's add a camera that is not in my collection. There we go. Otherwise it'll get turned into a metaball. So one of these middle frames, I don't think it's, yeah, because it's moving through the space, so it's not one continuous mesh surface. What we could do if this doesn't work, let me just try this with EV. I might actually need some help setting up motion blur. I can't really remember how to do this. If I just render it, can you render one frame and have it be motion blurred? I render animations so infrequently. This is, yeah, that's probably, so because you can set up the vector, oh, if you do it in a simulation zone, then you can define, you can find out what the value change is. That seems extra finicky, doesn't it? I'm just thinking, because then you would be able to basically say, well, it's moved this far, so I'm going to put this vector on it. I'm going to render this out as an, oh, what's it called? As a shader AOV. And then you can use that in Compositor to composite motion blur. I mean, I feel like that's a really ugly solution, but not impossible. I would say if you're stuck, then you can manually enforce that kind of stuff. I am going to just back to our metaballs here. I'm going to take my empties collection and I'm going to put this onto my group input as the empties. We'll be doing another one for meshes in a little bit. And then I'll also use a group input to control, let's make sure that we select our empties collection, there we go, to control our smoothing distance, which actually I will default to 0. And this will be our smoothing subtype distance, and that's fine. Minimum value should be 0. And now we can increase that to get those to join. And now we have another problem, or not a problem, but we have another thing to work out. Our volume cube is requiring a min-max value. So we want to know the bounds within which to calculate our volume. The smaller we can keep our volume cube, the more effective it will be. And in fact, you could even take this a step further with repeat zones and chunk your SDFs. If you were to, I'm not actually sure how you would do this, but if you were able to work out which ones were close enough to each other to become groups, then you could actually do a repeat zone so that you would have volume cubes running within the literally the minimum area. So right now, if I look at my 3D, I am always going to have even if this one is like way over here, I'm always going to have at least this area calculated. But it would be more effective or more computationally efficient if I could just have one volume cube here, excuse my drawing, and one volume cube here, and just have those separated off. Could use an arbitrary. Yeah. It's tricky for... It's tricky to work out that kind of thing from scratch. This is what you were asking earlier about whether or not geometry nodes is low level. This is one of those times where it's like, oh, I really wish it was just a bit more low level, because I want to break into that for efficiencies. Question from Cryo. I'm trying to set the tilt of vertices of a curve, but I'm stuck at the start. Can you elaborate on your question? So do you have a mesh or do you have a curve? Are you using the set tilt node? Because you have the set curve normal as well, which will allow you to set a custom normal vector if you want it to be like, oh, specifically point that direction. So something that I was doing literally yesterday was, let's take a Bezier. Oh, that's not the right one. A Bezier curve primitive. There we go, that'll do us. And let's use a curve to mesh with a curve line. And here we go, let's make sure our curve line is in the y-axis as well. So minus 0.5 to 0.5. Cool, so right now our set curve normal is pointing straight up to a value of 0.001. And if I was to point this instead in the y-axis, then you can see that it's pointing in the y-axis instead. If you wanted, what I was doing yesterday is I was pointing it directly at the camera. So I was taking the active camera node. By the way, we have an active camera node now, through an object info node. So this to relative, and I was using the location subtract the position, which is going to evaluate the position per point of your curve. And then I was making sure this was also aligned perpendicular. So this vector, I'm going to need to add a camera. There we go. Because you get some weird twisting like this, you need to make sure that your vectors are going to be aligned to the curve tangent as well. So we can do this by taking a cross product of the curve tangent, like this, with curve tangent into the bottom, and then we will do it again, but we'll put curve tangent into the top. And you can see if I just switch back and forth between these, it changes a little bit, but it basically preserves things to be just a little bit clearer to the curve tangent. So that's how you can do that. I have more information on that in one of the tutorials I did recently. Was it the last tutorial we did? Quite possibly. So if you want to know a little bit more about that free curve stuff. I have a braid knot curve, and I want to set the tilt. So a braid knot would be something like, do I have extra curves on? Yes. So you have a braid knot. And let's come back into here. I'm just going to pin my node tree. How do you want to set the tilt? Like, what about the tilt? How are you wanting it defined? Because generally, you would just have set this. We're going to be set radius of the curve on here as well. That is a curve object. Why is it not plane friendly? Oh, there you are. Yeah, so you can either set curve normal or you can set curve tilt, depending on whether the curve tilt is already aligned in a way that you're happy with and you just want to tweak it, like make an adjustment, or if you specifically want to say, I want it all to point specifically towards one thing, or defined per point. Vintran, hi everyone, what job should I apply for if I use geometry nodes fluently? That's a good question. I was working at Unity for 2 years as a geometry nodes artist. I was literally hired to use geometry nodes, so that's a possibility. Technical director, like a TD, that's an option, or just like a 3D generalist with a specialism in proceduralism. Environment artists, they're always sought after if you have a bit of proceduralism, because you're going to need to do, there's no way you're going to hand position every tree in your scene, probably. So things like that, probably. Like, I mean, what industry are you in? If you're in architecture, there's loads of opportunity for like technical creatives. Although you might want a little bit more of a like a formal education to be able to open some doors there, just because it's a bit more of a traditional industry. Right. Also, anybody else who wants to chip in there with ideas, do feel free, because I feel like it's such a big question and it's such a changeable industry as well. So it's always good for people to know. Okay, min-max of our bounding box. Kaito, as I contacted Erin for this geometry node, know that if you have the contacts, they could link you as as freelance making geometry nodes to multimedia studios. That's also very true. Yeah, a lot of like VFX houses. I mean, I have predominantly just made tutorials. I feel like this is, I'm not trying to flex by saying this, but I have not really tested myself with putting out a portfolio. I've never ever applied for jobs. I've simply been visible as using geometry nodes on social media and YouTube. And as a result of that, I get contacted every few days with opportunities within geometry nodes. So it's not like there's no opportunities, there's loads of them. And there's a lot of studios who are like, we want to use more Blender, or we want to start using a bit of proceduralism in our workflow. And they might just bring you in as a consultant. But I think the main thing, if you just want to just be visible, like if you're fluent in geometry nodes, just start putting out content, whether that's like mini tutorials on TikTok or Twitter and Instagram, or literally just posting your work and pushing it out there. There's a lot of people who are interested in proceduralism, and I think as well, like a lot of people don't understand what geometry nodes can or can't do, and there's an opportunity there just for you to literally go into a studio and tell people whether or not it's worth them investing in learning geometry nodes. And then you can potentially go in and teach them. So you could go in as a consultant, check whether or not they need geometry nodes, and then also offer them a service to teach them geometry nodes or to provide them with tools that they can use. So there's loads of things. You might just have to be a bit creative with it, because there are very few specific, you must know geometry nodes for this role kind of jobs. But at the same time, like, you can just invent the job that you want. That's generally how I've found that I work. Thank you, White Devil. That's very kind of you. Now, I hope sharing some of these more specific geometry nodes workflows helps people, because I find it super interesting, and I know it's not the most accessible thing to learn, and I also know my tutorials are not the most accessible thing, but it's kind of part and parcel with this sort of workflow. But if I can help somebody make something cool, then I get to see something cool, and I feel like that's a benefit for me. That's the payoff. The more geometry node stuff I see, the more excited I get. So really, I'm doing this selfishly. Yeah, the visibility thing is like a really big part of it. I just think with how the industry is, and as well, I'm 29. I'm at a level now where I have friends within my like age group who are creative directors or running studios. Like we, unfortunately for many people, like we are social media kinds of people, and we see people who are visible. And if you're on the tip of your tongue, like if I say, oh, I just want somebody who can do, trying to think of an example, like if I want somebody who can do cinematic geometry nodes and like cinematics, VFX, geometry nodes, then I'm going to go onto Twitter and I'm going to be like, oh yeah, Jesse can do it. Blender Essie, like incredible work. He's the first person that I think of because I've seen his work frequently. And it's just about like keeping people warm. If you think about it from like a marketing standpoint, you're just keeping customers warm. Customers just happen to be your potential clients. So yeah, if you think about it like that. So many amazing geonoders on the Blender Discord. Yeah, absolutely. It's just about visibility. I know it's not easy for a lot of people if you're not like naturally interested in social media. I know it's a weird thing to be interested in, but what's stopping people from just hiring programmers to make add-ons for them instead of having a geometry node specialist? I mean, so this is just my take on it, and it might not be true. When you have an add-on which is entirely Python, then there's a very limited amount of things that you can fix in it as a lay person. You can have really good commenting, and you can have ways of like integrating custom scripts and things like that, but you ultimately still need to know Python. What I used to do at Unity was part of like a bigger pipeline. There was a lot of Python stuff going on, but the tools that we wanted access to and wanted to be able to easily change, I built those entirely inside geometry nodes because then they were more accessible to a layperson. You could actually go in and you could modify them, and you could just go in and like add 3 or like whatever. It was more within the software that we were familiar using. So even if it was part of a bigger pipeline, injecting a little bit of geometry nodes can actually be a very effective way of making a tool more accessible and more configurable, because you just have to change a resource file that way. But I take your point. I think a lot of people just don't realize that actually you can do a whole lot with geometry nodes. With Python. And geometry nodes is like hot topic. So people see it often and they're thinking, oh, this is the thing that we should get. Especially if you're a hiring director, you're going to be going more on hype. So it's easier to think like, oh, well, everybody's talking about geometry nodes, especially over the last couple of years. So geometry nodes must be something which is incredible. Yeah, software developers are paid a lot. The average income at LinkedIn is $156,000 per annum. And that's just your financial compensation, like your pay. Then on top of that, you're going to be getting stock units, bonuses potentially, like car allowance and things like that. So yeah, software developers, crazy money. God, yeah, and if you know machine learning as well. Incredible time for machine learning engineers right now. Okay, let me get back into this. I'm sorry I take so many tangents. I think I'm actually just a bit chatty. So if I've got, we were looking at the bounding boxes, right? So I want to know how big my object should be so that I'm doing the minimum computation based on the amount of space that we have here. And a nice easy way to do this is actually just to make a proxy of this data by, if we take our instance 2 points, and then we instance on points an icosphere. And let's do it with 2 subdivisions just so we have a little bit more roundness. And if we set our scale based on this attribute statistic, now we have essentially a proxy object that is similar to our metaball size-wise. It doesn't have the right topology and we're never going to see it, but essentially this now represents our metaball object before we've computed it. We can then use a join geometry and pass this out as a new output. Let's rename this output on our node to be proxy. And we will take in the proxy from the previous loop and join it together. And now if I have a look at my proxy output, you can see that we have these spheres. And if I compare this to our metaball version, you can see that those match spatially what we're looking at. So then all we need to do, let's realize these instances and put a bounding box on it. And there we go. Now we know exactly how big our volume cube needs to be. We're going to add a little bit to the size based on our resolution. So I always want to be one sample bigger. You could go half a sample, but I feel like, yeah, one sample bigger is going to just make it a little bit more robust. You're never ending up with like a random flat surface on the edge of something. It should just keep it a little bit easier to work with, a little bit less prone to errors. So by default, we could just take our min and max into that bounding box, sorry, the volume cube, and then we have our resolution. You can see that just bunched up a lot. That's just because before we were sampling a much larger space, whereas now we're only sampling within the space we're interested in. Ooh, chat's going off. What's frustrating to me about geometry nodes is you can't yet do everything you can in edit mode. Yeah, absolutely, 100%. This is something that I feel like I'm actively pushing for. Like every time I meet the developers, it's always like, oh, I just really want like bridge edge loops or flatten faces or dissolve vertices, you know, like loads of these things that you just want to have a little bit more access to modeling, because modeling is actually really difficult inside geometry nodes. Shameless plug, I've actually got four courses coming out about procedural modeling inside geometry nodes. They're going to be on Node Group. They are currently in their final stages of being edited, so I'm hoping for a late April, early May release. They're architectural in topic, but they're actually just procedural modeling. Like, it's just that those exercises happen to be interesting to me to make, but fundamentally we're just doing procedural modeling. So if you're interested in spline-based modeling, a little bit of this kind of like SDF control, mesh control stuff, yeah, there's going to be like 13 hours of content coming out if you're interested in that. So that's, yeah, in the next month and a half, I want to say, hopefully 6 weeks, you should get access to those 4 new courses over on Node Group. So stay tuned for those. So back to our volume cube. We need to subtract from the min, and we need to add to the max a value, which is going to be our buffer. And our buffer is going to be based on the size of a sample, right? So it's going to be based on our resolution. And the resolution is going to be per meter. So how do we work this one out? Let's take another group input on here. So we've got our inputs. We're going to be taking a new integer input, which will be called density. And for a description, this will be points per meter. So these descriptions are just like hover help, basically. So when I hover over a socket or a value on the modifier, you can see that we're getting a little pop-up telling us what that is. So that's really useful to have that if you're shipping tools to people. So our density, if I do, I'm trying to think what the best way to do this is. Oh yeah, I'm scared excited for the day GeoNodes creates a decimate node that has a selection input. You have no idea how much I need a decimate node, like collapse decimate specifically. Oh, but also planar. That would be super useful. Yeah. It's one of those things where it's like, oh, but surely the code already exists, right? Surely all of these things could just be ported to nodes. But some of them are a little bit more complicated, so yeah. But decimate would be so good. Like, how useful is this to actually be able to reduce your topology based on curvature with vertex groups? So handy, so handy. Yeah, trays, exactly the same. Usually going from geometry nose tree to modified to geometry nose tree. And it's such a shame to have that kind of break, especially when something like, so let's say you've got a cliff, right? And you've got this really detailed sculpt of a cliff or photo scan of a cliff. If your camera is only ever seeing it from one direction, this whole area could be one face. Like, you don't need, so if you were able to basically use a weight map procedurally generated based on the direction of the view vector, like from the camera, then you could create this weight map that says, okay, well, like the dot product of the normal against the view direction is going to result in some values that you can create a mask for all of this, and then you could decimate that down to completely single face without losing any detail from the point of view of the camera, because it's distant land, you've got normal maps on it, things like that. All of that as procedural workflows, super useful. Tuli, sorry if I'm pronouncing that wrong. Hey Erin, I'm a front-end developer and a 2.5D artist. Do you have any suggestions for a career path that I could apply my art and programming skills in? What does a, forgive my ignorance, what does a 2.5 artist, like 2.5D, I'm assuming? Do you mean, is that like isometric? Let me just actually Google this, it's probably easier. Pardon my slow internet. Oh yeah. I mean, I would just do web dev. Honestly, you've got so much money heading for you. So if you can get into web dev, especially if you're going for like creative brands, I think if you're doing front end and you've got an art, like an art streak, and you can do, is it, oh, what's that name? There's an app that everybody's using recently. Is it called Rise? Like RIZE.app? That's all about like animations and interactive menus and things like that. It says it's for sale. That can't be the right node. Okay. Oh, you're a 2D artist learning 3D. Gotcha. I would literally just say like get into interaction design, get into UX. If you're doing front end, then you have this amazing opportunity for doing website design. And if you're getting into 2D and 3D, especially if you get into proceduralism, then you can do so much interesting stuff with like interactive web pages, with 3JS, with all of these different tools for implementing responsive design in a way which is super exciting and engaging for artists. And especially if you can get into things that are maybe a little bit more like full stack development, and then you can get into analytics and improving website click-through rate, and you know, doing like heat maps for clicking on a site, and doing I'm just trying to think of it, like SEO. Did I say that already? Basically, if you can go into a place where you can say, I can offer you a website which is interesting visually and engaging, and it functions in terms of it converts your audience to customers, I think that's a really strong position to be in. And if you can, oh yeah, Rive, thank you, yeah, RIVE. Yeah, so that's the thing about like interactive people. You can, let me just pull it up. They integrate with loads of stuff because they have their own wrapper. It's not free to use permanently, but you can definitely get into doing it. Sorry for the slow loading speed, but yeah, look, they've got WebJS, iOS, macOS, Android, Windows, Flutter, React, Native React, Rust, C++, Defoid, Tizen, Unity, Unreal, and Framer. So like Framer is that website builder, isn't it? So you can do all of this responsive stuff. Have a look into Rive. That's what I would do. I've seen a load of reviews recently of people popping off, super excited about Rive in terms of interactive design. So yeah, 3JS and P5JS. Yeah, is P5 the same as, is that cables? Is that, because there was another one called cables, or is that something else? Let me pull this one up as well. Yeah, cables.gl. Maybe this is wrong. It's visual programming. No, this is it. So this is for interactive design, node-based, just super interesting. Cables.gl. GL. P5 is processing wrapped in JavaScript. Oh, interesting. That actually does sound fun. You wait for the day Mantaflow gets replaced with a GeoNode sim. There's been a proposal recently on updating the asset browser or asset linking stuff within Blender, and I think that's one of those things which will be important for Blender to start shipping default default node groups. And at that point, we'll start getting actual power out of geometry nodes, because at the moment it's the I don't know what the word is. It's a place specifically right now for those who know how to use geometry nodes, which isn't very good. Like more default assets would make it more accessible for more people, because then you can just go in and you can tweak a few things, and by tweaking you then learn the system. So yeah. I feel like somebody else. Oh yeah, PZQ. Have I been asked for feedback from the Blender development team? Yes, essentially. I went to the last two Blender conferences. I'm not going to be able to go this year, unfortunately. But yeah, if you go to like a Blender conference, the developers are just there and you can talk to them. And at the last two conferences, we've had a little like geometry nodes meetup, which is always super fun. Because it's like a focus group, basically. Somewhat limited number of seats, but a really good discussion and interesting outcomes as well. And it's just a really good way for the developers to understand what's important to the users. Excuse me. Yeah, so I really like that about Blender, is how close your contact is to the development team, because it's just like, yeah, they're right there. They're literally right there. Let's just finish our volume cube setup here. I need to add a bit of buffer space. So let's say our density was 5. That would be 5 points per meter. And if I do 1 divided by 5, then that's going to be a distance which I can then add and subtract to this min-max. So that's just going to basically expand my bound space by 1 sample. And then we can take our density, and this is per meter, right? So we need to know how many meters our space is large. And then let's take a subtract node. We are going to be subtracting the minimum from the maximum. So let's cross those noodles. And then we want to scale this by our density. And that's going to give us a vector, which is 5 times, or whatever our density is, times greater than the meters dimension of our expanded space. So then what you do is you just separate that by XYZ, and this becomes your resolution. There we go. So now, no matter where we put our empties, I can move this up, but these faces always stay predominantly square, no matter how big this is, because we're not stretching the space anymore, or as we stretch it, we increase the resolution. So having a little system like this basically builds in a buffer region, so you never touch an edge, and it also creates a resolution which is dynamic to the size that you need. Split normals access in geometry nodes. We kind of have that now, don't we? Because we have this default smooth by angle node, which looks fairly complex inside, but there is now, it's an attribute, isn't it? Like the split. Oh wait, no, maybe it's not. Imagine you want to split a terrain measure. Maybe you would actually need to split. Oh, right, without extra steps. Yeah. Modifying normal data is unfortunately still read-only, I believe. It would be cool though. I mean, if you're just staying inside Blender, you can literally store an attribute as the normals, and then you can read that custom attribute as your custom normals inside the shader. Not very useful if you're exporting, but just something to be aware of. You can do that. Let's carry on here. Okay, so the next thing that we want to do in terms of making this like useful and better than metaballs is that we want to start playing with materials or having access to like material masks and things like that. So what we're going to do is we're going to loop over our geometry here, our SDFs. Yeah, so we're going to loop over our, where were you at? Loop over our geometry as many times as we have empties, and each time we're going to create a mask, and we're also going to create a minimum distance value so that we can have some kind of like color attribute being assigned or things like this. Global nodes for geometry nodes, yeah. Would there be a way to make sharp unions or weld unions or chamfered unions of the geometry? That is a good question. So in terms of like having a, like if I had a low smoothing distance, right? Then where these two join, let me make this density a bit higher. So right now they just combine, but we should be able to make them subtractive later. Can I just make that negative? No, that's not very happy. But maybe we can make it happy. So maybe when the scale goes negative, sorry, I know I'm jumping around a lot. That is just so much work goes into my recorded tutorials, literally just to fix my playing. I'm so distractible while I'm working. So let's say that we have this scale being a negative value. If it's a negative, so let's take a math node and let's just absolute this. Okay, so now it's back. Right, so we've just said even though your scale is negative, we're going to ignore you. Separately, parallel to our absolute, we're going to use a sign function, and this is sign. So this basically returns, if it was like -5, you would just return the sign, which is -1, and you can multiply that back in. So it's the accompaniment to absolute. Absolute ignores the sign, and sign just tells you what the sign was at that point. Supposing that this is negative, what we could do, I'm trying to remember how this actually works. Do you use maximums? Is that how it works? Do we just literally take a maximum node on, do I need to, I feel like there's something which I'm missing here. There's something about the way that we join SDFs together to create different functions. And I'm feeling like I'm going to need to actually just do a little test here. So if I just take 2 points with a proximity node in each of these, and let's go -0.5 and +0.5, and let's put a subtract on each of these so that I have a radius as well, and we will set this radius to be 1. I'm just holding Alt while I do this so that I'm controlling both of them at the same time, and then I can do a maximum. Minimum? Maximum? Oh, one of them has to be inverted, right? And then, here we go. So here's the balls. There we go. So if I wanted to invert the SDF by minus, you mean multiply by -1? And then minimum? Do I just, how do you invert the SDF? Well, so supposedly just multiplying by -1, right? But the problem is then that you have this massive space, which is like the outer. But then it's, yeah, it's the maximum. So it's multiplied by -1, but then do the maximum. Is that right? Oh, hey, mishmash mash. How's it going? Yeah. We've got, which one is this one that's on the left? Oh, so that is the one that we're removing. Okay, so multiply by -1 and then doing the maximum against the other. What does that look like in wireframe? So it literally is just like, you know, kind of like the Death Star, like it's just sucked in. Wait, the second one should be the one that's scaled by -1. Well, I guess it depends. As long as the one that is scaled by -1 is the one that's being subtracted, that's all that really matters here, which it seems to be. So if I, whoa, it should be max not min, yeah. So if we were to, I'm just trying to think of how we can switch this up so that it actually functions correctly, because it needs to do the minimum of the minimum ones, and then it needs to be subtractive. I wonder if we could actually just do like distance positive and distance negative, and then we can choose. Maybe I'm just complicating this, but let's say distance plus and distance, distance minus. And then we're going to have a final one, which is just our like density factor, which is going to be combined, right? So if it is negative, we can use this as a switch. Sorry to put you down a rabbit hole. The point of live streams is that they are a rabbit hole. So thank you for asking. Okay. So if the sign is negative, and let's also, yeah, we need that absolute back. I'm just trying to think, is this? Switch by sign, yeah. So I've got a subtract for the radius. That's correct. But when it's a negative value, then it's going to be false. So when it's true, because it's positive, it should just come through. And when it's false, this 0, whoa, we can put this as our original density, which is like just big number, just make big number. And then separately, let's use our distance negative now so that we can count up our inverted ones. This is going to go the opposite direction. Again, with the same, I'm sorry, I'm talking slowly because I'm working this out as well at the same time. So this float comes in here. I think this is correct. So this one is the negative scale, yeah. It seems a little bit lumpy, doesn't it? But it is only there when it's negative, so that's good. Why is it lumpy? If anybody knows why it's lumpy, that would be great, because it doesn't seem like it should be lumpy, because I'm doing the absolute... No, I'm... Oh, sorry, I'm being stupid. It's... Oh no, I'm not being stupid, that is correct. Oh no, I'm just dead confused. So we're doing the smooth minimum. Anyway, then what we can do is we can invert this second one. So we're going to multiply it by -1. And then we're going to do a maximum of that. Actually, let's do this after the loop. And so we don't need that density one. There we go, that's better. So we've got our min and our positive and our negative. So we're going to be doing the smooth maximum between the positive and the inverted negative and the distance is going to be based on our group input, which we've already set the smoothing value. That's a good question actually. Let me check that distance value. Oh no, that's worse. Okay, just let's see how we can do this. Okay, so this is correct, although not entirely correct, because now we're missing the bottom of this, like our values have changed. So let's have a look at our, oh, that's definitely wrong. It's nice when it works in your head. Absolutely. Okay, so this is not working because we haven't got our scale set. Now our scale is set correctly based on that absolute value. Okay, that's good. So now our volume cube is working correctly. Fantastic. Our positive value is working. Our negative value for some reason is lumpy. And it doesn't seem like it's based on this. Let's set it back to 0. Switch sign smooth min, smooth max maybe. So I need the sign, do I? So the absolute is definitely correct because this is telling us how big it is. And this is doing a smooth minimum inside here, so that also feels like it should be, oh, sorry, it's because of this distance negative. It's, yeah, because I had that set to 0, so that was the problem. But we need this to be massive because our ISO surface is being created at a value of 0, so we don't want to have our default value as 0, because otherwise we're getting that intersection, that sort of data collision. Okay, so in theory, is this going to work? You're going to, oh yeah, okay. I fucking love proceduralism. Now we've got subtractive booleans. Okay, that's wild. Thank you for suggesting that. Smashed it. Okay, let's rename this one. This is subtractive boolean. Okay, now we can go into doing our color stuff. So let's shoot over to the front. And let's sort this out. So after the flip faces, we've got another repeat zone coming in here because I want to take our surface and I want to assign to the surface, and it has to be done now after we've created the surface. So we want to create a new repeat zone on here, which is going to take our mesh. It's going to pass out our mesh. Inside each loop, we're going to find, well, we're going to create 2 bits of information. We're going to assign color, and we're going to assign an integer. No, we're not. We're going to assign color, like a random value, and that has to be done inside the loop. I'll show you why in a minute. And we're going to be creating our procedural masks so that we can say, okay, well, I want like number 2. I want to use that for some other color inside my shader. The smaller the bug, the more time it takes to kill, absolutely. Yeah, if it was massive, you'd just find it straight away. But it's just this is one of those stupid esoteric things that I feel like I should actually make a note about. And let's just plug this in as a value. Here we go. Must not be 0. There we go. Now we can remember that. Okay. So we need to run this loop as many times as we have objects coming in, because we need to do it per object. And let's take... I'm trying to think of what the best way to do this is, because right now we've only got empties. It's probably not worth me future-proofing this right now. It's best to just get through it as, yeah, just so that we're clear on what's actually going on. Let's take our empties collection. This might be changed later when we start doing our meshes, but for now, let's take this, and actually it's on a group ID, isn't it? So group input. So that is our empties collection. We need to do separate children, relative. Did I do that before? No. Make sure they're on relative so it doesn't move. Doesn't matter if you move your object. Maybe it wouldn't because it's a collection. Either way. We can then do our instance to points, ITP, on here. Could you use like a mesh type that spawns on the empty? Oh, so you would have like in metaballs where you have different meta types. So what I'm thinking of doing is actually just supporting arbitrary meshes using raycasting. Potentially using raycasting. Although it was said before that using raycasting inside a loop is potentially problematic, or at the very least slow. And one thing that I really don't want to have is this to be slow, because it's currently actually pretty fast. So we're going to do our instance of points, and then we're going to isolate per point, which needs to happen inside the loop. So let's plug our instances into our repeat zone as a second socket. This will be, let's leave that as instances actually, and this will be our mesh, that first geometry. Metaball mesh. We also need an instance index, or sorry, a loop index, so that we can do this. And again, I'm using repeat zones properly. Even though we're using a loop index, this has to be done iteratively, just because of how it works. We're calculating the distance from each thing, and we basically build up this SDF. Like again, we do a second one, which allows us to apply color. We're going to add 1. Let's rename this node to +1. 1 in there, and that's going to be our loop index. Geometry proximity plugged into the density factor of a volume cube would work. It actually wouldn't, technically, which I know is a bit of a pain, because it's like if I actually take, let's take a Suzanne mesh. Oh god, where are you? Oh, there you are. And let's do a proximity. Position onto that density. Oh no. Oh yes, okay. Oh no. And then we're going to need to subtract a little bit. So we can make a real blobby. Like this. But then if we have a look at this geometry, you can see there's 2 holes, because it's a distance within and without. So then you would still need to go and do your raycast to check whether or not you were internal or external geometry and delete 1. So we're actually going to skip that entirely, and we're going to use raycasting. It's in ETK, so if you just literally do like this, then you can see that we've got that mesh directly. And it's about the right size. It's we do have some limitations, so that's vertical, so I'll need to turn on accurate. And that's going to make it slower, because then we're using 6 raycasts rather than I can't remember what I was going to say, rather than 1. What's the current goal? Surface packing? No, so we're doing just, whoa, did I unplug something? Yeah. Yeah, so not surface packing, because that would be kind of its own challenge. You could, surface packing is just something that's really difficult. You kind of have to shimmy stuff around, and it's one of these things, I can't remember what the name of it is in programming, but when you have a problem which doesn't have one solution, you have to solve towards it. So yeah, what we're doing is SDF modeling. Well, actually what we're doing is we're building an SDF modeler with geometry nodes. Oh my god, I made rum truffles. Just so fucking happy. Although my rum is about 300 degrees. So they're all melting right now. Okay. Where are we up to? So we're going to take our instances. And we're going to separate the geometry, just like how we did before, based on instances whenever the loop index is equal to the instance index. There we go, that's making that selection. So exactly the same process that we did last time on the main loop. We're going to take our selection into our instance to points node, and we're going to do a geometry proximity based on the points. Hey Riaz, how's it going? I'm glad you turned up because you're still my mod. Okay. So we're actually going to need to find the sample position or index of the nearest face of the monkey, subtract it with the point of the volume cube, then dot product with the nearest normal. Oh yeah, actually that might be a good way of doing it, because we're going to need to, it's always going to create the surface at the raycast. And the distance is really all that matters. So if we could do distance from nearest surface. Yeah, I'll need to think about that. But yeah, doing the dot product to check the internals. But yeah, it's just a lot of sampling. I think that's the thing, is like we're trying to reduce the amount of sampling that we have to do within the loop, because those sample nodes are just not super fast. And potentially we could be doing this on quite a lot of high poly topology. Yeah. Yeah, I think I'll think about that when I get to it, I think. Riaz. Oh, you're working as a research assistant. Congrats, that's actually amazing. Are you at liberty to talk about what you're researching? So with my separate geometry, I'm also going to just, actually I'm just going to copy it. Separate geometry, take that attribute statistic on the instance scale. In this case, I think we can just do the absolute. I think that should work. Don't think we need to do anything with signs or anything, so we'll take that instance scale and then we'll just subtract from this distance. There we go, and you can see this one's just gone entirely black. Let me turn off my wireframe for a sec. That's what we want, because that surface is the is at 0, right? It's at a value of 0. So if I change my inspection, oh no, that's not helpful. What do we need to pass through? Let's pass through our instances as well. Let's make sure they're all going through. Oh, and we also need to set the number of iterations based on the number of empties that we have. So domain size, instances, instance counting goes into there. There we go. Let's click through our values. There we go. So you can see there's a bit of fall off here as we come around these different objects. Yeah, super useful having that inspection index, because you just want to check it. You can also see here where we've got that subtractive boolean, that we're getting that 0 value just on those spaces. So if you wanted to basically say, oh well, I've done this boolean and the inside of this boolean I want to be a different value, well now we're going to be able to generate a mask for that, which is great. This is fantastic. And in fact, we can take this value that we have now as the mask. So it is an SDF, so it's technically not a mask. what's the best way to do? So we're going to take our metaball mask. We're going to store a named attribute on here. This is going to be called, well, actually it's going to be generated procedurally, the name of it. And it's going to come from our loop index. So if I take the loop index and I go through a value to string node, now I have a string. Let's see if we've got some values on here. Let's make our, I wish you could zoom in on the spreadsheet. That bothers me that you can't. Riaz, making a VR app for teaching medical students about treating cavity of people with cancer. Oh, yeah. That's amazing. That's so important. Like, genuinely very important work. Training aids are they're one of those really interesting things. I have another friend who works in oil, and they train people, or they build systems for training offshore oil rig personnel, and they use mixed reality and these really interesting VR rooms. So they're not headsets, because they have like a group of people that go in together basically into these rooms, and you have like a 360-degree view of the space, and you can see all of these things. And then you also have like the HoloLens that is going to give you like a heads-up display so that you can look at stuff and be taught live, which I feel it's just so interesting. And like in those really high risk situations, especially like if you're treating people medically, yeah, just super important to be able to get that kind of training, especially being able to do that in a safe way is just, yeah, so valuable. Let me increase so if I just plug this in here into this store named attribute, then you can see that we've got these new attributes in the spreadsheet. For some reason, only 2 of them. If I plug that subtract in. Oh, right, yeah, because yeah, that makes sense. So it was only 2 because it was going off my viewer node, which was on inspection of the second or third loop. We're hoping to use some form of Google Cardboard. Google Cardboard was discontinued, wasn't it? But I know what you mean, like a mobile version thing. I did some VR like 360 stuff when I was doing my interior design degree, just as a way to show off schemes. And yeah, we used not Google Cardboard, but it was the same kind of thing. Basically, you'd have like the website go onto your phone, and then you could just like, yeah, super accessible. People actually used it during the degree show, which was cool because, well, not degree show, it was just like a show of our work, like an exhibition. But I feel like that would be so much harder to actually get people to engage with if it had been real VR, because putting on a headset is actually quite a difficult thing to make people use. So I'm going to take my value to string. I don't just want it to be called 0, 1, 2, 3, 4, which is the loop index. So we're going to take a join string, and we're going to add a new input constant string. There we go. And I will just call this one underscore SDF. And there we go. So now we have 0 SDF, 1 SDF, 2 SDF, 3 SDF, 4 SDF. And then we can use these within our shader to attribute different values to the surface. So if I was to come after here, add a set material node. Let's throw on a very basic material. Yeah. Shader new, which I can just call SDF. And let's go into rendered view here. And what was it? I think it was going to be 2, wasn't it? It was going to be our inverted SDF, so 2 underscore SDF in our shader. And yeah, this is giving us that surface. We can then limit this with something like a map range, just to bring in that 1 value right up to that edge. And it's still a little bit chunky just because it's geometry, so I might want to come just slightly off 0. And we also might want to increase our density to something like 30, just giving us a much cleaner edge there. And then we can use this as a, let's say the insides of these are going to be metallic, so I will set 1, 0 as a metallic value. And I'll also plug this through a mix RGB just so I can set the color on this as well. So, oh, we want to set the roughness too. So then we've got our 0 to 1 value, and then we can just plug this into roughness as the opposites of this. And also let's set shade smooth. There we go. Beautiful. So this is giving us, it's a little bit laggy just because I've got a very high density here. If I set that down to 15 again, it should be a bit more responsive. And we could even set smoothing value. I wonder if I should have smoothing subtractive and smoothing additive be separate, just because I might want to join these balls but have a hard fall off. And the way that I would do this is I would just set this group input here on the smooth maximum to be different. So let's add smoothing additive. And we'll have another input smoothing. Actually, I should just duplicate that one. Subtractive. That's too long. I don't like having long strings as my names, just because it's kind of a pain. Is viewport? Yeah, that's a good idea actually. Although is viewport doesn't change between solid view and rendered view, unfortunately. There's no like check renderer, which is a shame, because that would be super useful if you could set like a different resolution based on cycles versus solid. We're going to do this one on here. There we go. So let's join those together. But then have, oh god, 203. Oh no, I messed up. That's not good. I meant to hit backspace, but I hit enter. Oh, good lord. Okay, let's try that one again. I wonder when I saved. It should be fine, because I did actually save at the start of the... oh, that's pretty soon. I'll take that. I used to do these live streams and people would always scream at me to save, because after like 2 hours, it would be like, oh, I'm still using an untitled, like unsaved file. Let's just redo that. Okay, so group input, we've got smoothing plus and smoothing negative. Duplicate item. There we go. Smoothing negative can go in there. Smoothing plus can be a little bit more. Oh, it just looks so cool. I absolutely love modeling with SDFs, because you get just such interesting results. Love it. It's so blobby. Okay, so the next thing that we want to do is actually be able to colorize these independently. So, I mean, already we're in a situation where we're doing more than you can with default metaballs. Just because we've already set up this kind of different, don't you have autosaves? So you should have autosaves, but I use screencast keys, and it's only recently got an option. Where is it? For autosaving. I don't even have it turned on right now. So the problem is, if you've got a modal operator running permanently, it actually blocks you from autosaving. So I should turn on autosave, but it makes it a little bit crashy, so I don't. But yeah, if you're using something like screencast keys or any other modal operator, which, by the way, so I've got a 7-part tutorial coming out hopefully this week. yeah, hopefully coming out starting this week, about making a driving game, and that actually uses a modal operator to read a gamepad. So when you're following along that tutorial, hopefully following along that tutorial, what's a modal operator? One that runs constantly and captures things like mouse clicks. So when I press G, this is not just a transform, like a linked transform or a constant transform. It's currently reading my mouse position. And when I right click to cancel or I left click to confirm, that then ends the modal operator. So yeah. Cool. Okay, where was I? Oh, adding colors. Yeah. Sorry, I'm just like, my brain's just like, what's going on where? So if we take our subtracts, and I actually need to build this now into into an SDF, a general SDF. So not just for the current object, which we have here. Let's go back into solid view. And let me also turn down this resolution. 30 is a bit too high for real time. So if I have, I basically want to know what the whole thing is so that I can add a specific color or a random value for each one of these objects. It does get a little bit challenging. So you can basically override with your individual masks, but maybe you just want a random color. There will be some interpolation, and obviously if you drive randomness via an interpolated, like a smooth gradient, then you're going to get different randomness at each point. But you could use it as like the base for a noise, or something which is continuous. I'm just going to explain this as I show you. So let's just take our subtract, which is our distance, through our repeat zone. This is going to be our overall SDF. And it's not actually going directly to that, it's going through a minimum. Is that correct? Yes. So even though some of them are negative and some of them are positive, we should be able to get away with not bothering doing stuff like that. Am I on Manjaro right now? I'm not, unfortunately. I'm on, well, so my laptop is Fedora, just because I'm lazy and I prefer not rolling releases, just because I use it like once a week instead of every day. And I was looking at updating the X input library. So let me just show you this X input. Do I actually... It's on my GitHub, hang on. So there is an inputs library, but I couldn't actually, I'm not good enough at Python to set the inputs library up, which would be basically cross-platform. So unfortunately, the add-on, the controller add-on that I built for this, oh, I can't remember my GitHub now. The add-on that I built is based on the X input library, which is Windows only, which is fine, I think, for the majority. When I was looking at my audience analytics, it did look like maybe 95% of my viewers are on Windows. And because the X input library sets up a whole load of stuff automatically, like it's got a lot of helper library scripts in there, it was much easier for me to just set something up very quickly, like in a couple of hours, versus using the inputs library, which would be a lot more involved, for me at least. Is there a way to have infinity max value constant in GeoNodes? No, I don't think so. That's why I just use big numbers, like over here, where I was just like, oh yeah, 100,000, that's bigger than 0. So, yeah. What are we doing? Okay, so we've got our minimum value coming through here, and basically what I want to know is if I look at my metaball mesh, I'm interested in when So if I look at the whole SDF, and I need to make sure that my SDF value here isn't 0, it needs to be some big number, just like we had before. So now you can see there's actually like something going on here with different SDF values, and then there's the smoothing stuff going on. If I take my subtract and then I find a less than between that and is it less than? Yeah, between that and the SDF. Now I actually have a mask that is going to be changing. It looks a bit weird, but this is actually quite a good way of doing it. So that's one of them. That's the top one. That's the side one. Oh wait, one of these is the... Oh, that's the top one. There we go. So it's specifically doing it based on when it's smoothed out. Okay, so the reason I'm showing you this anyway is because we want to then mix a color, and we're going to be adding a color across each thing. So rather than it just being like add this one SDF mask and then another SDF mask and another SDF mask, we're just going to be looping across this and building up a general color over the whole thing. So let's take our color into the first socket of our mix node here, similar to the minimum. We're going to be taking our less than as the mix factor, and then we are going to be taking, I'm just going to use a random color from our loop index. So we're going to take a loop index to a white noise as the W. So you can see basically for each one of these, we now have a flat color which is different. You could use white noise, or you could use, what's the word? A random value node. But essentially, we now have random colors per loop. We can plug this through into our mix node. And if we view this result on our output, you can now see that we have a different bit of color for each thing. And that subtractive thing does make it a little bit more complicated, just because it's really... I wonder if we should ignore it for subtractive ones. That might be a better way to do this. Just because otherwise we're essentially looking at things which are like non-mesh at this point. And because these are literally, like these surfaces are inside that object, it's capturing that object. Okay, let's pull this back. So we're going to swap this very slightly. We're basically going to say, we're going to take the sign here. This less than, so we want to use 0. Yeah, so okay, so I can literally just multiply this by the sign. Yeah, that's going to work, I think. Interesting. I'm not sure if it's entirely working actually, because we've got this stuff coming up on the side, which I feel like that should be the green, because it's clearly closer to this point than it is down to here. Like that against that. I wonder, am I going to blur the colors? Blur the colors. Yes, I am. But I will do that after the loop, just because I don't want it to be heavy inside. And we'll actually blur it based on our what's the word I'm looking for? Our distances. Hey, Magnum. How's it going, man? It's been a while. Result here. This one's going to be our color, or actually random color. But if you have a random color, you can always, great thing about this, separate X, Y, Z, you actually have 3 random values. So it's just like free extra randomness. And you want that really, because if we were to take this and now blur it, which is going to make it look much better. So let's say I blur it a bunch of times, and then I was to use this as a new white noise, then you're going to end up with all of these problems around the edges, because you have this smooth interpolation, and it's finding a different value. Basically, it's saying, well, this value is different, therefore it's a different seed for the white noise. which is why I was saying you could use this with a noise texture like Perlin noise, because that is continuous noise. So even though you get some banding here, if you have a small enough noise texture or like a general enough gradient, then you can have it so that you're not getting that banding so badly, but it's still not great. So better to just use the random color, and that way you get 3 random noises just in case you need it. And we're going to store this on the geometry afterwards. So store named attribute, excuse me, we're storing a color on the point domain is fine, just because it doesn't need to be on face corners because we're not splitting by anything. And then what are we going to do for, I'm going to call this one underscore col, or maybe I should just col, I think, because then it becomes like a default color attribute. Yeah, I'm just thinking of how do we set our iterations here? We could do it by our points per meter with that group input. I think that's probably makes it feel a little bit more intuitive. So that was our density, wasn't it? So iterations, and maybe we even multiply it by our smoothing, so that the more smoothing we get, the less smoothing, the sharper the blur, and the more smoothing, the smoother the blur. That sounds about right. So we'll multiply that density by smoothing plus. Oop, oh my god, where are we going? There we go. So now if I reduce my smoothing density right down to 0, and we intersect these, then you can see that we're getting a sharp seam across those. That's not a good color. There we go. You can see we're getting a sharp seam. As I increase that smoothing, it's going to make that a little bit sharper. Equally, you could increase your density and then just a tiny bit of smoothing. There we go. And that's pretty clean. So if we want to use this in the shader, again, it's just an attribute, so we can use it nice and easy. And we will just use it instead of this red value. So let's use this as col attribute. And now we have a different color per ball. Fantastic. Okay, I feel like we're on to the exciting bit now, which is seeing if we can do this for arbitrary meshes. Drop my density back down to 20. Magnum has been to Czech Republic. Oh, you had an internship at Polygonic. Oh, that's cool. Polygonic do things like Botanic, don't they? And is there like a transport one? And they've got a water add-on. And I feel like they have another one that begins with E. Very cool people. The Beacon was the best thing you decided to go to. It's a great event. Definitely go if you can go again, because it's just always such good people. And that goes for everyone. Like if you like Blender, definitely see if you can get out to Blender Conference. It's such a casual event. I think that's what really surprised me when I went the first time, was how easygoing it was. Beacon is the Blender conference. So traditionally it's been in Amsterdam every October. I want to say like 26, 27, 28, like around then, end of the month. If you are in America or Australia or Japan, like that side of the world, there is also, having started this year, has it already been Blender LA, Beacon LA? I mean, it's much too late to get tickets now. I think they sold out like super fast because it was so competitively booked. Dre's is an event that changed your life. It's pivotal. If you have not seen Dre's talks plural, then go check him out on the Blender channel. Okay, 19th to 20th of April. So actually it's this month. Hosted by Autotroph. Autotroph run like CG Cookie. They're like the parent company. So if you know people like John Lampole, they're a part of it. Very cool. 2 days it looks for. It looks like. There's no list of events yet. But definitely have a look at this and yeah. So if you're on that side of the world, you've got the LA one to go to, which is in April. And then if you're on my side of the world, then you can go to the Amsterdam one, which is in October. Very exciting. And they're just so fun. Like, the community is so cool, so friendly. And then you can just like, yeah, like nobody's trying to sell you anything. It's not like a big software conference where people will get, like, you don't have Adobe pushing stuff down your throat. It's just people are excited to share the stuff that they're excited about. And it's just very wholesome and everybody's very supportive. So there we go. Okay, let's rewind. Let's go back to the beginning here. I want a second collection of meshes. Just meshes? I'll call it objects because then we can split for curves as well. Is that a good idea? Curves have a custom radius, so that might be possible, or easy, I should say. And we can still just do like distance from edge, curve to mesh, distance from edge, and capture the radius. So that's probably going to work. Yeah, let's go for that. So let's, in our objects collection, we're going to be adding Suzanne, of course, and a cube, just scale the z-axis. Oh, how are we going to do negative? Like, how are we going to do subtraction here? If I want to plug that through the side of Suzanne, chop off her ear, give her a little Van Gogh. Then, I think tickets, by the way, for Beacon, I think they were like 340, I think, last year. I want to say. It was around that, anyway. It was around 300-ish. But it's fully catered, and it's all-day events from like 9 a.m. till... I think we were getting out at like 8 p.m. and going for dinner. Like, everybody just goes out and hangs out together. So in terms of like the enrichment you get from the event, I think it's a massive one. So yeah, definitely go. I'm probably not going this year, by the way. So I'm aiming for 2025. I'm in the middle of a very challenging house renovation. Also, I got fired from Unity, so that doesn't help me financially, because they were paying for all my tickets and everything last year. No bad blood, like it was totally amicable separation. It was just part of Unity's big restructure. So we should be able to get object scale here again as like a negative positive thing. And I think I should just do it for overall scale. So I'll scale this one by -1. The difficulty is that if you then apply the scale, like if I just apply the scale on this, oh, but then it's inverted. Ooh, maybe that's the interesting bit. Because if I do a raycast on this, what am I going to be left with? Maybe this will already be inverted just because they flip normals. I honestly don't know. Thanks for hanging out while I just invent this stuff. I'm sorry if this is not as planned as you were expecting. Oh, I wanted to add a spline as well. Let's grab a Bezier, and I will apply a scale, and then let's change the radius of one of these to be less. Okay. So we're going to do the same kind of idea. Coming down below, you're going to need a group input. 2 collections, as in one for subtractive and one for additive. That might work. I might need to do that. It's just because my empties, I've got it so that if you scale it negative, then it will become subtractive. And I kind of want that same, I like that workflow paradigm. And I feel like that would just be a nice way to work with the meshes, because then you sort of feel, it feels consistent. Let's take a new collection here for meshes, and we'll put this one up under our empties. Or actually, this is just objects, isn't it? So I'll call this one meshes and curves. Now, I'm just doing that in the description, so it's on hover help. And then we want to turn all these off. Go into solid view. Where is everything? Oh, I didn't select it. So we've got our objects collection. Here we go. I need to make sure that I can separate geometry by instances. And we need to pick these one by one. So index is equal to, oh yeah, so separate children definitely. Great. Okay. So that's our basic setup. And again, we're going to be taking the instance domain here. So let's find our domain size for instances. Is going to be 3. So that actually, it's always good to just sense check this stuff. I need to do, if anybody has any good ideas for how to present this, I would really appreciate it. So I've got this idea because I keep getting questions from people that are largely the same, or like it'll be repeating the same question, or a lot of people having the same question. And it's, I want to make a tutorial about debugging, and I'm not really sure how to explain how to debug stuff to people, because to me it seems quite simple, like just click through with the viewer node and look at the spreadsheet. But I feel like, yeah, I don't know, I don't really know. I think with a lot of these things where you've worked out a system sort of intuitively, it can be quite difficult to express that to people. So if anybody has any ideas on how to explain how to debug efficiently, or even just like what challenges you have with debugging, then definitely let me know, or send me a direct message or something. Because how to debug motion blur ghosts. I also don't know how to do that. But so more in terms of like debugging code or debugging geometry nodes, to try and work out like, why isn't this working? Like, how can somebody find out why it's not working? Why not another geometry nodes modifier that applies an attribute to the object with a menu switch that selects additive or subtractive? That's actually not a bad idea. Actually, that's a very good idea. Because then I'm just looking for an attribute on the instance. Yeah, Marcel. Let's do that. That's a great idea, actually. Thank you. So let's take our cube. We're going to add a geometry nodes modifier. This one will be called +/- and this one is going to be called, oh well, what's going on? Oh, it's just local view. CG matter. Right now, Tom, we are doing, so we've got our different colors. We've got additive and subtractive empties. So I can make that positive or negative based on its scale. And we're just going to be breaking into, let me add a different one actually down here. So we're just going to be adding into, so fucking cool. We're going to be adding arbitrary meshes now. So we're going to be having a look at how we can take Suzanne, this random cube and a curve, and turning them into SDFs and having them draw politely with our empty setup. What was I doing? Yeah, so for our cube stuff, we're just setting up a thing which is going to be, by the way, would you be interested in reviewing geometry nodes projects of viewers and giving criticism? I absolutely would. I did a portfolio review a while ago, and I don't know how useful that actually was, but doing like a, I see it on art. I follow like a lot of fine artists, like painters doing things like painting clinics, where you send in paintings and they'll do paint overs, and it's just called a clinic because they fix things basically. But I think that would be quite a cool way of doing it actually. Basically just people sending me a bunch of files, and then I could just like go through one or two and be like, okay, this is how we do it. And also like part of understanding a file is debugging it, like understanding where different things do. So that would be, yeah, that would actually be a great, Marcel, you should like come on and be like a content evangelical for me. Just come up with ideas. You could make a pack of small project files which have bugs that you encounter a lot. Ah, that would actually be cool. Node puzzles for practicing debugging. That is actually a very cool idea. I have an idea. So there's a guy on Instagram and TikTok, and he does a lot of 3D printing stuff, and he made the Geometry Nodes Dojo. I think that's what it's called, which is basically like a bunch of different exercises when workflow, don't worry, you're like, this is still the beginning. 2 hours is very little time for my streams. Yeah, so they'd have like a bunch of exercises and you work through it and you come up with solutions if you can, and you basically learn stuff through that. What I would like to do is basically have a course kind of similar, which, I mean, it would be a paid product, which I know not everyone's happy about, but it would be essentially like 20 different things framed as a question. And I think the best way of learning, and the way that I've learnt loads, is just from the Discord help channel, because people will ask stuff like, oh, I've made something which makes electrical wire posts, like pylon poles. How do I now join all of the cables together? And little questions like that. Like, it's a very scoped down problem, but it's a very good way of you actually learning. Like, oh, well, actually, I need to learn how to create or select a bunch of positions based on some attribute, or based on some mesh topology. I need to understand instancing and indices to be able to manipulate geometry such that you can control where you're instancing. And just generally creating things like that, which is like a very small challenge, but it just gives people a really clean sense of progression working through a challenge without them needing to come up with their own projects, because not everybody is very project focused. Like, being project focused is the best way of learning. I don't think that's contentious to say, but I think people, like a lot of people, don't have the free time or the interest to make different projects. And so, yeah, having that kind of like other people's projects, basically answering people's questions, is a really good framework for building up a course, building up a way of learning. Let's see how we are. Just tuning in. Oh, Zephyr, yeah. Are we making... We're not using metaballs, we're rebuilding metaballs to be... We're basically rebuilding meta objects in general. Well, actually, I'm calling it metaballs very loosely. We're building an SDF modeler with geometry nodes. That's the more general... yeah, Marcel, I will... Send me a message on... Are you on Discord? That's probably the easiest. Or if not, then you can send me an email. And then... Yeah. Just... It would be great to have that as like potential fodder if I can get around to doing this first video, which after I've got these 7 videos for the driving game to come out, which is actually really cool. It's like a full driving game. I wonder if I can show it actually. I wonder if I even have the add-ons installed. Let's see if this is going to work. Got a controller. Do I have X inputs? Maybe not. Maybe I did it in 4.0 actually. Do you know what? I think I did. Bear with me. Let me pull this up. Everybody likes driving. I made it last summer, and it's literally taken me until April to get videos made. So it's just... I'm not the fastest person. Do I have a version of Blender here specifically? No. So we might just need my joystick add-on. That's a good question. Let's just test it now. Let's see if I can get it working. I hope it's working in 4.1. We're going to see now if I need to update the scripts. Add-ons, X, input reader. Let's see if this is going to work. System console. Something's not happy. Oh, photographer. Oh, I've got a really old version of photographer actually. Let's see if we can install these. Pip is already satisfied. Downloading. Let's see how this does. Yeah, I think I built it for 4.0. Actually, I think I built it for 3.6, but then I did port it for 4.0, and I just have loads of like, if app version starts with 3, then do this, and if it's 4, then start with this. Okay, so we've got pip installed. We still good? X inputs successfully installed. Okay, I mean, I think that thinks it's done. So, whoa, what did you, I have no idea what I just pressed. Let's restart Blender. Sambo. Are these streams a regular thing, by the way? Because it's my first time catching the stream. This is my first one in 18 months, but I used to use it for, I used to do streams fairly regularly. Oh yeah, shit, yeah, it works, baby. I don't know if you can see that, but I'm, like if I press, you can see on my screen maybe, some of these things are updating, and that's just literally reading joysticks. New glasses, oh thank you Mel. I'm actually about to get new glasses, so that'll be, yes, there will be, I will change my look again real soon. Open, I hope this works. Am I hooking into joy.cpl? I don't know, no, I don't think so. If I press play, oh gosh, and then we monitor. Okay, something's definitely gone wrong with my parenting. But the truck drives. Let's see what's going on with this camera controller. Do we have some constraints on here? So the cool thing about this is basically it's all working inside a geometry nodes graph, and everything's working, like it's constantly solving. And yeah, so things like the wheels, there we go, the wheels will turn for you, and as you move they're working, and you've got reversing on here. Actually, I feel like, did I add reversing lights, or was it just brake lights? Oh yeah, just brake lights. So I've got brake lights working as well. Something's up with the camera parenting. I know I'm showing a broken version right now, but the game is going to be released, not the game, well, I guess the game, because it's just a Blender file. It's very simple, it's just a few node groups. The videos, the tutorials, they're going to be coming out as of this week. So I've just been getting back the content from my editor for them, and they're looking great. So yeah, I just need to make some thumbnails. Hopefully a little bit less cursed thumbnails for this, because it's actually like I put in a lot of work, and I want people to click on it. So let's get back to this. Let's do our menu switch, because I've never really used them. Is Blender a semi-game engine? No, I would say no. It's a really good, I'm using a simulation loop. That's all I'm doing, is I'm using literally just a simulation zone, because it updates every frame and you can read data from the previous frame. And if you're a bit clever about how you use named attributes, you can do basically anything. It's not fast and it's not optimized. I mean, that game runs at like 60 FPS, so that's not a problem. But if you had like loads of trees and you were doing LOD systems, which don't really work properly because of how the instancing works in Blender, I mean, you could do a bit of camera culling maybe. I don't know. I mean, yeah, the tutorials bring you up to a base level where you can basically create a game that you can drive around in and have relative physics and you can collide into things and you don't go through them. I do not include enemy AI, but I do include a score system, so you can go around and collect those Suzannes that were in the map and it will add to your score, and you can you can have a new high score and things like that. You'll kill for global attributes. Yeah, I know the feeling. I literally just have like a separate object that has attributes that behaves like global attributes. So it's good fun, but it's a very stupid. It's like you shouldn't do that. Basically, you shouldn't use simulation nodes in that way. But it's a really good way to learn simulation nodes. So I hope you enjoyed that series. Let's see how we can do menu switches, because I don't really understand these. We are switching between Boolean, I guess. And this can be called added. Is that how you spell additive? That feels wrong. No, that's correct. And the other one is going to be subtractive. 13 attributes is the current limit. Oh, what? For named attributes, you can only have. Is that's going to be a problem with my metaballs, because we're procedurally generating attributes based on these. Let's see how many times we can create attributes. So we're adding. Oh, you're chugging. Okay. SDFs are so cool. I would say that's more. Yeah, that's loads. That's loads. That's 20 columns. I've got 18 auto-generating attributes there. I can't remember how many of these are new. There we go, that's fine. Okay, so we've got a cube, additive and subtractive. And then do we just plug that onto the front? No, that's really cool actually. Oh yeah. Oh, I've not actually used menu switches before, but this, I can imagine this being really good actually. That's really interesting. This being geometry nodes, it exists on. Could have 3 attributes in one using a vector. You could do, or you could have 4 if you use a color. Yes, exactly, yeah. So I'm just going to store this attribute. It is a Boolean. I know because this is just an on-off, this could have literally just been a Boolean, but this is just very pleasant. Boolean on the point domain, there we go. Yeah, Riaz, I felt honestly so old, like 3 or 4 weeks ago when I was coming back to geometry nodes. So I was doing like a lot of a very similar thing with when I was at Unity, and so I didn't really have time to explore like 4.1, 4.2 alphas, things that were coming out. And then when I came and it was just like, okay, personal project time. Oh man, there's so much to get into. There is so much. Plus minus seems like a very appropriate name for the attribute. I'm sorry, this is what happens when you let an artist start coding. I'm sure there's never going to be a problem with that coming up as a string in your code. Okay, I'll change it. I'll change it to add sub. There we go. We can. That feels less janky. This one can be subtractive. And let's add that same one link modifiers. This one can be additive. And on our curve, this one can be additive as well. Do we want a default for our menu? Is additive. There we go. coming back to our metaballs, let's come down here. We are going to need our instances, oops, on our node, here we go, our instances. We're going to need a new one for our loop index. I'm really hoping this all just works the same as before, because I'm not prepared for it to not. I think it'll just work. We're going to add F2, add 1, so we're incrementing this. Each loop instances come off. And there we go. Okay, that's our curve. We need to realize, I think, at this point, and then we also need to separate components based on whether it's a mesh or a curve. I think this is the right way to do it. Just thinking, because right now there's going to be nothing in this. But if we were to have a curve at this point, and if we capture the radius, and then we do a curve to mesh, because I need it to be a mesh to use with a proximity node, distance from edges. And let's plug this distance up into into a new socket, which is going to be called distance plus. There we go. And we are also going to be doing just the same as before, a smooth minimum. Oh wait, not quite yet. We're going to be doing a subtract to find our radius based on that radius there. Remember when we had to do 0, 1, 2 for menus? Yeah, yes, so much. There's so much. I was literally doing that yesterday in the shader because we don't have a an index switch in the shader, which feels like that would be such an easy fix. So yeah, I was like switching between 7 different image textures based on a random number, and it had to be like those arrays of mixed nodes that you would add together. We're going to be doing a smooth minimum on these between the previous loop's distance function and the current one, and we need to make sure this is a big number. 100,000 will do it. Using a value here, must not be 0. The reason I'm using such a big number as well, rather than just being like 0.1, is because we're doing a smooth minimum. So if the value here is too close to 0, you're actually going to end up growing your metaballs when you increase your smoothing distance, because it's kind of creeping towards the density of everything. If you think about, yeah, it's basically, you're just dealing with different density space at that point. Our distance factor is going to come off our group input, so that's the same as before as well. Smoothing plus goes in here, so that's for the joining. And if I just read this into that density factor, this is not quite right. What do we need to do here? So we have our curves, and the viewer here is saying 1 point. Oh, okay. Yes, so it's subtracting a value which doesn't exist. So this subtract, this is confusing. For the big number in the beginning, why not do the first iteration before the loop? That's a good idea, actually. The only reason that I would not do that is just because I don't want to duplicate the nodes. It's because I'm lazy, essentially just because I'm lazy. Let me take my loop index into this equals as well, just to fix that up. Whoa, did everything just go black? Interesting. Ignore that for a sec. So yeah, so this subtract, this distance is coming up here, and it's actually being evaluated on the volume cube. The volume cube does not know the curve's captured radius. But what we can do is we can sample the nearest. See, this is when it starts getting heavy, isn't it? I think it's probably we're just gonna have to accept that actually this is just going to be how it is, because we need to know what the radius is of the curves, so we need to sample those, and we also need to know where the mesh surface is, so we're going to need to potentially raycast for that, and we'll check performance when we do. Yes, so what we've got here is we need to sample nearest. I'm going to go for sampling nearest edge, and we're also going to sample sample index, and again that's going to be edge. Based on that index, value is going to be here, and this index goes in. You just understood the title being a Bob Ross reference. It is, yeah, the joy of painting. Just you gotta just have a nice time, happy little trees, lots of happy little accidents. So we've got our, I mean, this should work. Let's just do it one time. Yeah, look at that. That looks atrocious. Let's do this based on the points instead of edges. So let's change both of these to point. Is that going to smooth it? Not really. Distance from edges. That stepping is yeah, croissant, exactly. Happy little node trees. How are we going to stop it from being like this? Because it's going to the nearest point. Can we go back to the edges? See, that's losing the end. That's actually changing it quite a lot. Yeah, and clearly we do have mesh at the end here. Honestly, just create a mesh from the curve. I mean, I could do. Oh, and then just treat it like mesh to SDF. Riaz, you're really clever, actually. This is why you're like a research associate. Okay, let's back up and try that. Can I do it just on the instances? That would be useful. Separate components. No, I can't do it without realizing them. But then we could separate to do I just do it in the repeat zone? Yeah. I was trying to think of a way of doing it a little bit neater, but actually it's not going to be any faster to do it that way. So we've got our curve. This can all go away. Curve to mesh. We're just going to use a curve circle. Oh, but then we're not going to get semicircular caps, which... Do we want semicircular caps? Because they are actually really easy to make. So let's do a curve circle. We're going to set our resolution fairly not too high. We're going to do 16. But then if you do like a resampling density that's higher, we could always set our resolution based on the density of our volume cube, but that seems complicated. So we'll just do it like this for now. We're also going to instance on points whoa, I just saw that my internet just dipped massively. Are we back up? There we go, that looks better, man. Literally just everything went red. Okay, instancing on points, we're going to instance in half we need a UV sphere. Which is going to have 16 segments, just the same. So let's actually put this on an integer. And the number of rings can be this multiplied by 0.5. Just gives us something approximate. It needs to be a positive. Oh, is the video being choppy? Or is just right now? Sorry if it's difficult to watch it. Hopefully it's passable. I'm going to delete geometry, delete geometry for the top faces. I'm actually going to just do this with 8. We're going to go faces here, and we're going to be doing a compare where the normal vector direction is not equal to the upward vector with an offset of 0 degrees. And our epsilon is going to increase to pi by 2. There we go. So that's just giving us the top of our cap, which needs to then be instanced on our spline. The rotation needs to align Euler to vector. For the previous approach, you could have used geometry proximity edges instead of sample nearest. So I was using the geometry proximity on that curve, but I also needed to sample the radius. And the proximity wasn't sampling specific attribute data. So that's why I had to do the sampling. So the stepping was just based on the sampling, basically. Yeah, because some of them are closer to one point rather than the next, and it wasn't interpolating across the edge. So I could have done it with like sample nearest surface if I had any kind of surface, and that would have given me like a barycentric transform interpolation. But yes, that's... Anyway. So, what are we looking for? I need to align the z-axis to the vector curve tangent. And the curve tangent needs inverting or scaling by a value depending on whether or not it is the start or end point. So let's grab an endpoint selection, the start size through a switch, integer. So the start size is going to be -1 and the end size is going to be 1. And then we can also align locking the z, the y-axis, to the normal. And then if we join these two together, oh, that's not quite right. We also need the radius as the scale. That's, oh no, that is correct actually. There we go. What do you know? We can realize our instances. Join geometry. We don't actually need to merge just because of how we're going to be doing our mesh to SDF stuff. It doesn't really matter whether you have contiguous geometry. So this will actually be fine, I think. Yeah. Okay, so let me just organize these nodes. This is Control J. This is our curve to mesh. I wonder if we should be transferring UV map data. Would that be crazy? Should we actually add, or do you want UVs on your SDF mesh? Because we could do that. We could make it so that you're always going to get a little bit of interpolation where one point goes to the next. So we're not going to be able to completely get a hard edge, I don't think. No, I don't think so. So we would just be sampling basically the nearest. But we could do that inside our second loop over here where we're re-evaluating each part of our geometry. But yes. So we're going to need to take these things. Basically, we're rebuilding our proxy stuff like we did with spheres before. We can now take this, join geometry with our meshes. Yeah, that's fine. And then we can plug this through, rename this as proxy, and then we know that we've got the proxies on the output on the outside, and then we can make sure that our bounding box stuff is all correct. Plug that proxy through onto our join geometry as well. And now when I look at my output proxies, and we make sure that we're doing it correct for the instances. There we go. All right, I'm actually going to just reduce both of these. Is it Alt S? Yeah. So there we go. So now we should have a little bit smaller to work with. That's a bit nicer. Okay, so now we just need to work out. Oh, do you know what? We also need to work out whether or not something's got additive or subtractive Boolean on it, and just make sure that that is preserved through our meshing of the curve. So let's just fix that first. So we can just use a statistic node to evaluate that really quickly. It's float is fine, point domain is fine, named attribute, which should be add sub, and we'll just find the value that's on here, which is giving me a value of 1. Oh, that's interesting. Maybe I don't need to do it because it's because it's instancing on the curve, so it's already pulling it up, and it's curve to mesh. So we're not actually, yeah. Sorry, I thought we were doing some donor geometry stuff. Okay, so that actually should all be working. And then if we step through our inspections, we should have, they're all on. Okay. So one of these needs to be, or one of these ought to be negative, I believe. So we've got the cube is subtractive, and so that should be off. So when we come into our metaballs, what have we got in here? If I mute that and we come up into So okay, so we're joining for our proxy stuff. That comes to the end. We need a second join for that previous loop stuff. So we only want to look at one loop at a time, actually. So here we go. Add sub is negative there for subtractive. Let's add a new input for the subtractive one. So we'll just add distance negative there. And make sure that we're doing our big numbers thing at the beginning. Okay. Yeah, sorry you're having to see me like think live. Let's just there we go. Fix my normals. So what I would generally do is, I guess, a raycast with a proximity node, like one raycast, one proximity. That would probably, I would think that would be the fastest way of doing it, because then you can check what the nearest surface normal is. And then you know like the distance, and you have a direction. So you know whether you're a positive or a negative distance function. So then it becomes signed, and that gives you your value for 0 by interpolating between a positive and a negative. It knows where that 0 position is. So if we take our join geometry through a raycast and through a geometry proximity, interested in the proximity to the nearest face, we're going to do a subtract and a position. So from the current position to the surface, I believe, is this direction. That is going to be our ray direction. There we go. And then I've got my hit normal. If I do the dot product of the hit normal against the ray direction, so if you think about being inside a sphere and you've got this point here, it knows that it's trying to get to this point on the surface. So that's its ray direction. And then the hit normal at this point is also in the same direction. So in this case, the hit normal and the ray direction are the same. Your dot product output, in fact, we could even make this easier by doing an equals direction, angle offset of 0, epsilon of pi by 2. So what I'm basically saying is when the hit normal is the same, is equal to the ray direction with 0 angle offset, so we can just ignore that, and an epsilon of pi by 2, meaning up to 90 degrees, then we know that we are inside the mesh. And if we're inside the mesh, then we take our hit distance, multiply by -1. So I'm going to do this through a switch, integer. This is my boolean. If it's true, that means we're on the inside. So -1 for true, +1 for false. This should hopefully be our distance function. So if I plug that into my smooth minimum over here, oh, that's slow. Oh, that's real slow. Gotta go make breakfast at 1 p.m. Thanks for hanging out, Trace. I appreciate the support. And okay, this is messy, but also kind of beautiful. So what's going on here? So, okay, first of all, let's fix our bounding box issue, because right now, clearly, it's not quite where we want it. And that's actually really easy for us to fix. We can just take our proxy from down here and join it to our proxy from above. Like that. There we go. Now we've got all our space. And now we need to work out why it's breaking everything. Is raycast faster than sample nearest? I would assume so. Yeah, I would assume so. Because either way, you're going to need to sample the nearest surface normal and the distance to that. I mean, if you sampled it as a let's try this. Sample nearest and good night, Sadi. Thank you for hanging out. I appreciate that. We also, so we've got our points. Actually, we want to be sampling faces, I think. Oh wait, maybe we could use, sample nearest surface is almost certainly not. Either way, this is going pretty slow, right? This feels choppy. Let's try sample nearest surface. That's fine. We are going to be sampling a color because I want to sample the normal. Yeah, no, that will work actually. No, wait, what do I want? No, because I want the hit position and I want the hit normal, don't I? To work out if I'm inside or outside. And I also want the distance, which I can work out from the position. So at the very least, I want 2 vectors. And I've tried quantizing them into a single vector before, and the loss of accuracy is too significant. So, yeah, that's kind of a pain. If you have a sample nearest, that's going to be doing your 3D check one time. And then if you're doing a sample index, that should be very lightweight because now it's just index checking. in theory. So if I was to do the hit normal, or the nearest normal, and the nearest position, then we can compare. So if we subtract the position from the surface position, that tells us our direction, and then we can find out whether this is going to equal the direction. Wait, is that right? Direction? Yeah. And again, we're going to go 0 and pi by 2. That should give us something. I need to work out if I'm actually doing these in the right order. If I'm trying to get from one point to another, and I want the positive factor, then I take the destination, I take the origin from the destination. Yes, so surface position subtract current position. And if this direction is the same as the surface normal, then that means that we are inside. Yeah. And that is going to be the length of this vector, is the distance to the surface. Is this any faster? No. I mean, it's certainly doing something. If I just take one of them at a time, let's just check. Let's remove Suzanne for a second. Okay, which one are we even doing at this point? Okay, so this, oh dear, this, it feels like this should be something that works fairly easily and out of the box, and I'm really not making it work. What's this repeat zone doing? Oh, inspection index, out of range. That one looks like it's working a little bit better, but it really isn't. 360 from the raycast versus 260 from the sample nearest. Yeah, so that's why I'm just working on this spline piece right now. Maybe if I merge, I mean, surely that shouldn't be right though. If I merge by distance on this, yeah, that actually makes it worse. What are we trying to do? Okay, so I think we've worked out that the raycast with geometry proximity is slower. Sample index is faster. Oh, is this the problem? Yeah, that was it. Make sure that your sample nearest is doing the same as your sample indices. Let's check for speed. So that's 79 on points versus 270 on faces. Okay, definitely keep it to points then. That's a crazy difference. We are going to need to do a little bit of surface smoothing because this is clearly not ideal. Geometry, that's pretty lumpy. I would say this is not usable in production at this kind of quality, so yeah, we will need to fix that. And we definitely have this set to a big number, so it's nothing to do with that. Let's come in here. Oh, and then we can do. Okay, so something else is not working now. Let's just frame this up. We'll make sure you're renaming things. So this is our mesh 2 SDF. Cheap. There we go. Our proxy. That's a very strange one for that to be working in that way. It does have the normals on the inside, so that's try using geometry proximity instead of the second sample index. Yeah, good shout actually. Do our speed checks. And let's bring up a timings down here. So that's 121. Oh yeah, I mean, yeah, correct. Geoproximity for points. Oh, actually much slower. 227 versus 123. Although it does give us the... Oh wait, no, we're calculating that separately. And that's even doing it to faces. It's around about 50% slower using geometry proximity. Oh, sorry, on points. Oh yeah, and it's 4 times slower doing it on faces. So we're going to stick with that sample index, I think. Hey, erasers, how's it going? So right now, I'm seeing if I can turn meshes into SDFs efficiently and with some kind of smoothing between them, and then ultimately join them with our point SDF stuff. Basically just building a metaball system within geometry nodes, which has a ton of customization and features, being geometry nodes based. The problem is that I'm running into problems that are, yeah, not super pretty, which is definitely on me, but yeah, that's, yeah. Okay, let's take out our Bezier as well, so I can just work on one thing at a time. Let's grab our cube. We're just going to be doing one iteration. Got our separate geometry. Got our mesh. And nothing's being created. When there's no curve, nothing is created. So we're definitely not making any UV spheres or anything. Join geometry, we've got our cube back. We've still got the correct attribute on here. Yeah, so that actually doesn't make any sense. What if we just come directly? Oh, thank you. There's so many things you can add to these. I can literally just do geometry nodes like indefinitely. There's so much you can keep adding. I think the problem is that, like, when I get into situations like this, I genuinely have no idea. Like, why isn't it working? Is it a face normals problem? Because I inverted those face normals, or I corrected the face normals. So that shouldn't be a problem in theory. If we take this out of the loop, maybe the normals are, yeah, maybe. In which case, maybe I've got this subtract back to front. But at least when I look at this here, with face orientation turned on, like if I scale this negatively, or there we go, you can see it goes red. So I know it's face front side out at the moment. So I guess maybe our Bezier curve, but I don't think so. I think the Bezier curve was being created properly as well. If we have a look down here, yeah, so this is also red on the inside, and that was turning into that was being raycast properly, or like curve to mesh. Oh wait, mesh to SDF. My brain's getting frazzled. Okay, let's take our objects. We are going to realize instances, pass them onto this, and let's take our Bezier out for now as well. Beside that cube. So no loops, let's just check our maths. If I invert that, that's definitely not right. If I set this to -1, 1, that's doing exactly the same thing. it's because it's the nearest point. It needs to be the nearest face. It needs to be the nearest face. At which point it might be faster. Don't know what that's doing. But yes, so it needs to be the nearest face because basically each point, like a point here, was going to the corners, right? So that's why we were getting that weird pyramidal shape coming out of the faces. Okay, 73 milliseconds. And if we do this with a proximity node to the faces, what does that give us? 110. So still slower. Understandably, because this is going to face centers, like the average position of the face versus the nearest interpolated position of the face. So this will be still slightly less accurate. I don't know what this is doing, but that might need some clear up. So we might have to like delete geometry, which is too far away from our proxies as well. But let's just take our geometry plus here into that density. Let's update our samples here to use both faces, and this one is also going to be face. We can cull that bit. And then we've got these two meshes that come in as well here with our smoothing distance. Interesting. Oh right, yeah, and then we need to run this 3 times. Oh no. Okay, Suzanne's eyes not helping. So we also, let's just make Suzanne manifold real quick. And we'll do that with a remesh node. There we go, something like that. I think that, I think that was a, yeah. For that weird face, maybe add a bit of buffer to the bounding box. Yeah, there is. There's one sample extra. Yeah, for debugging, it depends on the individual's users. Yeah, for sure. Like, I know fundamentally under the hood what a lot of these nodes are actually doing. So it's easier to debug because I can look out for things. Yeah, we are actually, maybe I need to add 2. That improves it a little bit. I reckon actually just, man, this is not fast now. This is very not fast. So adding meshes is definitely going to slow down the system. Maybe that's just a limitation of working with geometry nodes there. I wonder if you could do, nah, I don't know. I was just thinking, I wonder if you could, because we're having to do all this face stuff here. Let me just, actually, yeah. Let me just bring back the raycast. I just want to compare it now that I've got this working with the proximity here. Yes, to faces. We're going to subtract from the position to get the raycast direction. And then we're going to check when this is equal to the direction in direction 0, pi by 2, and same again up here. That becomes the switch. Oops, there we go. And that comes off the distance. And this should be smooth minimum. So for 18, 16 to 2110 and also broken. Yeah, considerably broken actually. Oh wait, no, that's correct. Well, either way it's slower, so I'm not going to debug that. Okay, so then the next thing here is, these are not intersecting, are they? No, that's good. So our smoothing can increase. Let me draw my density down to a bit less. It's weird that that's not really, feels like it's not really interacting with the cube, which is a strange one. I wonder why that would be. Let's check our wireframes. Yeah, I feel like that should be, working. That's strange. We do actually need to split this still, don't we, on the add and subtraction boolean, which is just another smooth minimum. There's an artifact on the top, is there? Let's have a look at that. Oh yeah, that's weird. Oh, so so that's because of how this sample index, basically, you're finding the average position of the face. So it's can't you sample nearest surface position and colors? Would that be cheaper? I thought sample nearest surface was really heavy. The vector. Oh wait, so yeah, color. Combine color. Separate XYZ into the XYZ. Position. Eval on domain. We're looking for the face domain integer for the index. Wait, why am I doing the oh, to get the normal? Yeah, that's pretty smart actually. Separate color. Combine XYZ. Yeah, I always thought sample nearest surface was super heavy, but let's do that. Normal. And it's cool that we have all of these different ways of doing the same thing. Like to actually just have that kind of flexibility, I really appreciate. So that's our face normals. And our positions coming through here, and then we can do our all of this stuff, can't we? Yeah, definitely losing that and getting this weird artifacting in the middle of the faces because of it being based on the face centers rather than, or I assume that's what it's erroring on. Pi by 2 equals means we're inside, so true is -1, that's correct. This. Okay, and we're running from right now 340 going up to 250, but we've got some artifacts. What can we do about those? I mean, it is faster, but it's definitely erroring as well. And that is the face domain we're picking. Interesting. Pulling it off the face corner seems a little bit more accurate. At least in terms of the errors it's throwing. Is that fast? Is that faster? It's more accurate, and we're going 250 there. I know this is not super accurate, 273. Maybe that's actually faster. That blows my mind if that runs. Turn down the smoothing. Yeah, and that's... Damn, Marcel. Okay, next thing, let's do a little bit of cleanup. Let's get rid of this rubbish that we don't want. Oh, that's going to be a bit tricky, actually. I'm not sure why there's errors on that point, and I'm just wondering if I can actually do it mathematically, because I don't want to do it after. This is our new cheap. I don't want to do it after our volume cube, because if we do it then we're going to be losing. We're going to be mixing some of these errors in with our empty stuff. Missed to SDF. There we go. That's actually a really cool way of doing mesh to SDF. I might have to use this in... I need to update ETK because it's super behind the times. Like old. Like some of it isn't working, which is a problem. I'll probably do those as live streams actually, because that's a nice way to just kind of hang out and show people the workings out. Yes, okay, let's do our... Let's have a think about how we can fix this. If we take our proxy and we do a geometry proximity to faces, and we just need to say less. Oh, but then we've got the problem with smoothing. You're using a separate geometry proximity and sample nearest. What are you using the geometry proximity for? Because you've got your proximity, you've got your position and your length coming through, like your distance. That's given to you already by the proximity. By the sample nearest surface. Yeah, definitely interested to know why you're doubling up there. I'm a bit worried about doing this like less than because of unless let's just base this on our smoothing. Smoothing plus. So let's take a group input node. We're going to say anywhere which is greater than the smoothing plus distance from the surface. If we have a look at this. Yeah, these are all flashing at me. So what I will do is I will simply add them. Oh, they're still there? They must be really negative. Yeah, okay. That's not right. That's worse. Also worse. Maybe I can just multiply this by some big number then. Sometimes these rough and ready approaches are actually just perfectly fine. There we go. Oh, but then is that going to... Oh, but no, because we're doing minimum, aren't we? Okay. So, hang on, wait. Let me frame this up just so I remember what's going on. So all I'm doing there is basically saying anywhere which is greater than the smoothing distance, which I think should mean that even if I do a bunch of smoothing, we shouldn't be deleting it, in theory. And then yeah, and then we're just making it big, but then because we're going to be using the minimum to combine it up here, what are we looking for? Math. Oh, we're just going to, no, we could use a, We should use a smooth minimum again, shouldn't we? Because we've got that smoothing value. So smooth min against our smooth max here. Yeah, that's looking good. Take another group input here. This is our smoothing plus because it's a minimum node. It's all coming together. Look at this. Okay, I appreciate this is no longer real time, so I apologize. But we are now supporting objects, which is cool. And is vector direction into a switch faster than dot product into a sine node? Do you mean... Oh, yeah, I see what you mean. Dot prod, oops. So dot product will compare two vectors basically and give you the similarity. Do they need to be normalized? No, it shouldn't. It should just be fine, shouldn't it, on the sign? And then the sign is obviously giving us +1 for positive, -1 for negative. If they're the same, it'll be positive, which will mean that they're in the inside. So I would need to invert that. 440, 432, 444, 435. Is there any way for me to just trigger an update? 431, 442, 435, 443. I mean, it's, yes, it's faster to use. Is it? It's within error. It's within error. I would say it's like potentially faster, but it'll be yeah, like a couple of % or something. Yeah. Well, I'll go with that. It's a bit neater, isn't it? Yeah, thanks for all these tips, man. I really appreciate the the help with this. Okay, this seems more or less to be working. Let's check that we can actually join these things together. Yeah, baby. Actually sticking them on. Oh, and we should do our subtractive stuff. Okay. This is great. How did we even do subtractive stuff before? So we're doing our switch based on the sign with some big value. That's our radius. So it's after... Oh, right, yeah, because we're not doing radius. So it's after this, whether we're doing this smooth minimum or this smooth minimum into the distance min, or distance negative, sorry. And yeah, I can just copy these two switches down, and they're driven by that boolean, by the attribute which we've got. That's going to go like this. This is going to go like this. You go into this one. You go into this one. And this is an attribute, named attribute. Add sub. We need to make sure these are the right way around. Oh no, what? The fact that you're thanking me for tips is insane. You and CG Matter are the... I mean, that's crazy. That's crazy to me. Tom, CG Matter is incredible. Like, he's got such a ridiculous brain for this kind of thing. Yeah, it's just a wild community. So massively thank you for saying that. That means a lot to me. These actually need to be switched around, don't they? Okay, this is now working, but add sub is not working because this cube should be subtracted. You were making a stream of the Colosseum. Yeah. Oh, that was SDFs as well. It's like you just like coming for SDFs. That was a crazy stream. That was actually super fun to get into. Let me know if I need to change internet as well again. My OBS is flashing. Riaz, that was not 2 years ago. It was 4 years ago. So, just so you know. It was like peak lockdown. So, in fact, I think it was before I redid my office, which is crazy. That was in my old office. What are we looking at now? So this cube should be subtracted. The reason it's not being subtracted, but it shouldn't be included. Okay, let's come back to this density. Just interested in these cubes. Just interested in these objects because I want to make sure basically that distance plus does not have this in it. It shouldn't. Oh wait, because add sub is on. We're gonna need to sample add sub, which we can do. Okay. We can join add sub into this index because indices are always positive. So if I make, I'm going to multiply this by add sub as a switch between +1 and -1. There we go. And then what we can do is the index here, this alpha, we can just take the absolute because that's fine. That's just ignoring that. And then we can take the sign of this alpha, which is now negative and positive. Actually, I could just do greater than 0, couldn't I? And that will just give me add sub back. So greater than 0. There we go, and that should be my addition subtraction. Great. And actually, I had them the right way before. There we go. So there's that, and you've lost the picture on your old account. I unfortunately don't have the piece of paper anymore, Riaz, so I'm gonna need to. Let me see if it's still on Instagram. That's going back a long way there. I mean, I can actually just explain it to you because it's just min and max, isn't it? In fact, we could build something that does it for us. That might be fun. Let's see if it's in here. Oh, it's not yet. Definitely a different account. Unlucky. So let's build a little debug tool. This is one of the things that I really like about working with geometry nodes, is that it's actually a really great visualization aid. I know I keep telling people I'm going to be making a free maths course, but I actually am. I actually am going to make one. So if I take, I'm just going to take a bunch of points. We actually, trying to think what the best way to do this is. We could find out. Yeah, okay, let's take a curve line. I'm going to resample it. I'm going to make the curve line 0 to 10 in the x-axis. And just resample it a bunch. There we go. Now, if we set the position of this, just offset with a combine x, y, z. So we're just dealing with float values And maybe I should put this into a group like this, just so that we have it. Let's actually make this a bit higher resolution, and we'll plug in our z-axis into our group input. So right now all we have is a little linear graph drawer. Okay, and I can set this, the z height of my curve. Maybe we should also do a curve to mesh, just to make sure that it's got some visibility on it. Let's grab a curve circle. And we'll set our radius a bit smaller. Great. Okay. If I were to just take the position X, then you can see for every value along the x-axis, we are increasing the position, the offset in the z, right? So at a value of, let's turn off wireframe. You can see that as a value of 1, we've gone up 1. As a value of 10, we've gone up 10. And you can do loads of things with this, right? So I could do some maths on this. For example, I could multiply it by some value. That's going to change the angle. I could maybe even just put this through a sine graph, and then my multiply is going to be the wavelength of that sine. So you can play with the numbers and just kind of debug this in an interesting way, and just kind of understand the maths a bit. But if we had, let's take 2 of them. So we're going to do 10 subtract x does the opposite, right? So 10 subtract 0 is 10, 10 subtract 5 is 5, 10 subtract 10 is 0. So then you end up with the opposite direction. And then if I was to take a minimum function, right, between those two things, sorry, not mix, if it's to take so another math node set to minimum, and in fact this is probably a good way to show smooth as well. Then it's 0 all the way across. What have I done? Oh, because I did that off the y, sorry. So you can see here, these are the first 2. And the minimum value is basically just going to find whichever value is closest to 0, or actually closest to negative infinity, all the way across. And then when we have a look at our minimum one, we can see that it's just pulled off those bottom 2. Equally, if you do the maximum, it's going to be whichever values are highest for each of the inputs. Smoothing, like smooth min, smooth max, that is going to give you that smoothing in between those 2 gradients. And so that's actually what we're doing with our SDF joining. So that's fundamentally what we're doing there. And that is basically, this is the drawing that I did for Riaz. Just literally 2 lines on an X. So, yeah. There we go. Oh my god, reliving old history. Any ideas for beginner to intermediate challenges as exercises? I would say just, I'm a big believer in being project-based, like having an idea for a larger project. So maybe you want to make I don't know, maybe you're interested in furniture and you want to make a furniture generator that can make all sorts of different types of chair or something like that. You know, that's maybe a slightly forced example, but it shows you the kind of idea anyway. You just like pick something that is in line with your interests. Okay, this cleanup, I feel like I should do the cleanup for both positive and negative. So same multiply, oops, and we're going to take this one off the bottom one off the negative, top one off the positive. There we go. And then what we're going to do is we're going to take our, oops, oh no, that was right. We're we're going to do a smooth minimum on the two positives, and then the smooth minimum on the two negatives as well. So we've got our distance plus here will be joined to the distance plus up here. So here we go, distance plus going into that smooth maximum for the subtractive boolean, and this is going to come off that cleaned up add. And then we're going to do the exact same thing below our smoothing plus, because this is where we're joining things together, coming off this other add. And then this should come off our smooth maximum. There we go. And now we've subtracted this cube from these and the sphere from those. Oh, my neck. So the next thing, yeah, so something that I've actually just been doing yesterday, I will show you this. I'm not really sharing it because I've got into a really, like, just a habit basically of, actually I need 4.2. Basically, because, so when you run a business as like a personal enterprise, it's very easy to get into the mindset where like everything that you do is about the business and all of your free time is about the business. And every time when you wake up in the morning and you're checking socials, you're not checking your socials, you're checking your business's socials. Like everything becomes work. And one of the things that I've been doing, or thinking about really for the last year, is wanting to get back into making art. And so something that I've been doing yesterday was actually just like starting to get back into making art. And this was just like a super fun little mini project. But like I really love painting. And so building a project like this, which is, it's totally unfinished, but there's a lot of things in here which are like, oh, this is like a thing which I really enjoy, like painting. And then you've got a lot of stuff in here which is in line with things which I'm interested in, like geometry nodes, so like all of the bushes, all of the placement of ground stuff, little helper tools like building, like how do I color all of these different things even though they're all using the same textures, you know, like stuff like that. Little helper tools that just apply attributes and then reuse them. How do I do these cables? Well, obviously that's geometry nodes. This ladder is actually just like an extruded plane, but I wanted to make it a little bit like wobbly and things like that. Or the hedge over here in the background. This is just a curve on a bunch of points in a cube that I made. You know, like if I go into edit mode, you can see that this is literally just like a box. But geometry nodes makes it into this kind of abstract, squelchy brush mark. So it's just super fun to like have a personal project that you can challenge yourself with. And yeah, I just think pushing it into the thing that you're interested in. So like, even though I'm interested in painting in a fine art sense, I'm still looking at this as like, how can I actually elevate my geometry nodes workflows and test out the new nodes and think about how users are actually going to be using geometry nodes. So yeah, Eraser, that's probably what I would do, is just anything that you are interested in, any project that you're thinking of or working on, or, you know, you want to like design a kitchen, or you're thinking of getting a new dining room table or anything like that, just try applying your thinking to that project via geometry nodes. I think that's what I do anyway. I just, yeah, force it through geometry nodes every time. And I think that works quite well actually. Or helping people on Discord or Stack Exchange, things like that. That's also a really great way of learning, because you're getting real world, like little real world tests all the time. Somebody's like, oh, what about this in this context? Okay, next thing that we want to do is fixing our colors. And hey, Eshwar, how's it going? I'm going to fix our colors and maybe even apply UV maps potentially. I mean, probably. I think probably not. We're 4 hours deep right now, so I'm gonna not force you to watch me set that up. We want our second repeat zone to. What do we want it to do? We want it to build. Oh, we're going to need to do another SDF, aren't we? Using this setup here. But I wonder if we can actually, because we've got this proxy set up now. I wonder if we can actually store, okay. For each one of these proxy elements, we're going to store the loop index on it, and that's going to allow us to separate it, even though it's just like mesh. We basically need a group ID, and for that we're going to use the loop index. So let's store named attribute on here. This is going to be I'm just going to call it IDX. It's going to be an integer on the point domain, that's fine. And it's just simply going to be the loop index. Like that, that's fine. So when we're looking at our proxies here, so basically just so that I don't need to repeat all of this stuff, I could put it into a node group. To be fair. Maybe I should put it in a node group. How computationally expensive is this? I mean, it's almost doing nothing. Yeah, okay. Seeing as I'm going to have to do little bits anyway, this is probably the best approach. What's this sign doing? Oh, that's okay. Do you think it's do I think it's still worth working on Node++? A lot of the built-in things are geometry nodes, or should I remake it into more complex node groups? So what I'm going to do with ETK is not all of it needs replacing from the ground up, but I will be rebuilding every node individually from scratch using the original node as the framework. I also need to rewrite the Python side of it because there's a few tweaks I need to make. And I need to make actual documentation, which I feel really bad about. Somebody actually wrote like 80% of the documentation, and I just never released it. And that work is not wasted. I just need to actually host it on my website. And I will do that, and I will build upon that as I rebuild all of the nodes. But yeah, I would basically use your current add-on as a framework and then build the new nodes using it as the framework, because yeah, it's just going to make you faster versus having to redo everything from scratch. But there's so many things, like I want to add all of the physics stuff to ETK so that people have node groups for like rigid body collisions and cloth simulations and stuff like that, because that's always fun to work with. And yeah, there's just so many bits to add. But yeah, as for you, I think Node++, you've got loads of nodes in there. But I think remaking it, I don't know. Oh, Marcel, thanks for hanging out. Take care. Yeah, I don't know. What would you make into more complex node groups? I feel like the more complex node groups are actually less useful to a lot of people. Most people want relatively low level things, just not as low level as geometry nodes currently is. You know, if you can give somebody like a fill holes node, that's, in my opinion, low level in terms of the utility it offers, but it's relatively a complex thing to build. So, yeah. Okay, where am I going with this? Sorry. We need... I'm just going to put all of this... I'm going to put all of this into a node group because I think that's what needs to happen. All of the curve to mesh stuff, all of this join geometry up to the end there. Control G. There we go. Oh, thank you. I'm also looking forward to the ETK remake. It shouldn't have taken me this long, and I apologize. I feel like I've sort of failed the people who've bought it because it's so long overdue. So long overdue. Come in here, we're going to be deleting that second value. This value, what is this value actually? So this is add sub that boolean. This length, oh, that's the SDF. There we go. Geometry, SDF, addition, additive or subtractive. There we go. Geometry to SDF. Yeah, documentation would be great. It's the thing is, the documentation exists. That's the bad thing. I really just been sitting on it, which is such a which is not good. Okay, so now I've got which resources, paid or free, would you consider helpful in terms of learning the individual nodes? Oh, that's not sidetracking. Also, that helps me segue onto something. In hopefully the end of this year, I'm going to be, this is one of those things that I don't know if I should tell people because it's the kind of thing that would be really easy for somebody else to just do and then release for free. But I will be doing like a full course inverted commas, not like guided course, but essentially an encyclopedia course or a compendium, like a geometry nodes compendium, where it's like everything geometry nodes, like essentially video documentation going through every single node, every single socket, every shortcut features, like everything about geometry nodes, not in terms of exercises, but just in terms of like, oh, this is how smooth minimum works, this function, this is what it looks like, here's a bunch of use cases for it. Not something like, oh, you need to, I don't know, like most of my courses, all of my courses so far have been exercise based, so project based, where it's like, oh, we're going to build this thing, we're going to look at building this thing. And then it's just working through an exercise, kind of like my YouTube videos. But yes, definitely in terms of having that kind of just an entire broad stroke foundational understanding, that is something that I will be doing later this year. In terms of what resources already exist, my Discord, there should be a link in the description. But if you are not on the Discord, if anyone is not on the Discord, it's just Erindale XYZ. You can join it at that's just a random invite, but let's go with that. I just dropped that in the chat. I'm sorry, the chat is probably, or like the video recording is probably lagging a little bit behind. But yes, so that you just search in here for like let's say align camera, align tilt or something like that, and then you'll just end up with like loads of people giving information. Here's one, jump to this message, and there you go. Now you have like an align tilt to vector node group set up, and there's all of these things in like resources that people just dump resources in here and node group setups, which is super useful. So yeah, I honestly just check. Now I'm just sort of blowing my own trumpet, but check my Discord because it's probably the best single resource for geometry nodes information. And other than that, I would use the documentation. It's actually pretty good if you can get your head around it anyway. Okay, so now we've got this geometry to SDF stuff working. Don't need that proxy because that's going to be generated for us. We've got in here, I need another collection info for my objects. And I'm going to join these together into the instance count. And that's going to set how many times we do our repeat. Yes, I do recognize you from the Discord. It's just, I want to make sure that I canvas that information because I feel like some people don't realize that I actually have Discord. It's like there is so much on there. It's not just like a community of people asking questions and chatting to each other. It's like, actually, 4 years, 2020, I think it was June 2020. So 4 years of people talking about proceduralism in general. And then 2-3 years of people talking about geometry nodes as well. So yeah, there's just a lot on there. Okay, JC, back in my day, yeah, everything was shaders back then. Everyone was doing vector displacement. Okay, I need to separate. We're going to separate instance based on this. Oh, but then we need. Oh yeah. After we okay. But you betrayed us. I'm sorry. Vector displacement was amazing. Honestly, that was the best November ever, both in terms of like the number of people doing it and also just the results were so incredible. It kind of got a bit easy with geometry nodes. Maybe we should actually do like a vector displacement live stream or series. That would be a good time. I do miss those vector displacement days because they were crazy what people were doing. Yeah, actually nuts. JC, you made a run cycle. You made a character running out of a sphere that was vector displaced, fully animated. Ridiculous. Yeah, those were good times. They were great times. Okay, what I'm doing right now on my little nodes here, I need to know how many of these instances are empties. Oh, maybe. Yeah, no, I think this is probably the correct way. I need to know how many of them are the empties so that at some point I can switch over to using our geometry to SDF versions, which needs to come after a realize instances. Maybe it doesn't need to. Maybe it can just realize instances because empties will disappear. I made a massive greenhouse out of early 2.9 geonodes. That is true. That was actually very complicated. When I look back at those node graphs, somebody sent me a message the other day being like, oh, I'm following your Blender splash screen tutorial. It wasn't really a tutorial, but I'm amazed and flattered that people will follow a 14-hour tutorial or 12-hour tutorial. But they were like, oh yeah, can you send me the old ETK? Because I'm doing it in 2.93 because of all the attributes. And that's just bonkers to me. Like, that was such a complex system to understand and to use all of those attributes back then. It was crazy. So yeah, but props to them. That amazing work. So what I can do is I can realize instances. I need to make a bit more space in here. Oh, it's all getting a little bit crushed up, isn't it? Okay, let's make some general space. So if I realize instances while they're at empties, then but then some of them are going to be curves, and they're also, I'm just thinking of domain size stuff here. maybe I could actually just use an accumulate field instead. Set this to integer, group ID is 0, total is 0 because there's nothing here. It needs to be a domain size, I think. I'm actually planning on releasing a video on geometry nodes. The advanced tutorials are non-existent for Russian segments of YouTube. Oh, interesting. Is there anything I should know in terms of workflow and teaching? This sounds like a joke, but make your... I don't know how big your screen is, but for example, I use a resolution scale of 1.4. I use a cursor scale that's obviously massive, and I also use Windows scaling to make everything bigger. So everything about my screen is like really jumbo sized for me. That is very useful in terms of workflow, like for other people to follow what you're doing. If you're making jump cuts between your mouse being in one place to being in another, then you can, it's very easy to follow a large cursor, or at the very least have like one of those circles around the cursor. I also use screencast keys. That's, in my opinion, the best way of getting your overlays working, or like your keyboard shortcuts visible. And it's nice as well because you can, like, when you add something, you can see it's coming down here and it's telling you what that operator was. Another thing that's worth remembering is try not to jump around too much. I do this too much, but if you're... Oh, and zoom in as well. Actually, I literally have a list right now for things that I pay attention to while I'm doing my tutorials. So if you have a camera, talk to camera, because otherwise there's no point in having the camera. Ask questions during the tutorials because that will engage people with it. So you can even just say like, pause the video and have a go at doing this thing that I've just described yourself, and then come back and we'll do it together. And that's just a really good way of getting people to engage, because you can pretty much guarantee that 99% of people won't bother and they just want to watch the video. But for the 1% who is engaging a little bit more with the tutorial content, that can be a really nice break for them to just like take a pause, actually think about the problem, try to engage with the problem, and then you can help them if they can't get it right. Shortcuts, it's always good to just say your shortcuts, like how I always say like Alt-S switching this, or like Shift-Alt, or like, yeah, Shift right click, drag for adding reroutes and things like that. Just get that into your habit. And explaining your intent, I think that's a really big one, to tell people what you are intending to do before you do it. And then when you actually get to it, people understand much better about what it is that you're doing and why you're doing it. So I think those things it just primes people basically. So that would be my advice. How can I enable the option to search for node inputs so the right node will be added? Oh, you mean like how I can drag off this absolute and just add like add or multiply add directly? Is that what you mean? That's a default thing. So if I just Shift A search and then I do add, it's not going to come up. So this add menu is different. But when you drag off a socket, you can search, you can see it's giving me autocomplete options here, basically. So it's context specific. If I drag off and vector socket, you can see it's also giving me math nodes. So if I come off a geometry socket, for example, then we're coming to other nodes. Does it not work in shaders? No, it does work here as well. It's a node thing, but it's specifically about drag and search. So you can see when I drag off, I get that plus icon next to my cursor. That's specifically, it's the drag search functionality. Okay, what are we up to? Yeah, I also never used to drag search, but then as soon as I started doing it, it's like, oh, that's so fast. So it became a workflow for me. Hey Riaz, no worries. Thank you for checking in. Hope everything's good for you. If I just add the point count from meshes and curves. This is going to tell me whether or not there are any meshes or curves. And then if there are, then we switch geometry. And then we're looking for the true value. So that's when we can use our geometry to SDF. I don't actually think I need the geometry directly because we're not passing around. Yeah, we don't do anything with proxies on this end. We are just interested in the SDFs. Oh right, so that subtract, that can come back here. That's our surface, that's our ISO surface for the points. While using simulation nodes, I always encounter the problem of simulation not playing even if you start from frame 1. That shouldn't happen. Have you tried turning off the cache? Like if you have a simulation zone, here we go. Under your physics tab, there we go. You've got this cache option. Like if you bake, does it then work? Or if you turn off caching, sometimes I've seen people having problems with caching in the past. So you might find that getting that turned off will actually help you, potentially. Right then, this whole section here is going to take a little bit of debugging just because it's fairly confusing. Let's. Oh, okay, so if we switch this to a switch and then we use the SDF, and then we use the other SDF for this one, which is going to be when there's no when this is empty. Switches are great because the Boolean is evaluated first. Basically, node trees are evaluated right to left, or at least the information to evaluate is checked right to left. So things like this switch, it will look for which parts are going to be on, and then it's just going to evaluate those parts. So it's not going to evaluate too much, basically. It's always going to just limit. It's a good way to optimize your node trees. That's what I'm trying to say. Now, does this do everything I need it to? Oh, so that sign is down here as well. So I need to make sure that so that we're not taking account when add sub is negative, I think. So we use the previous volume when it's black. So I want to also multiply this by add sub. So that's going to be right, yes. So we'll take this through our switch as well. So that sign from the bottom is going into false, add sub is going into true, and this output is going into that multiply. Hopefully that's going to work. Is it possible to select an edge loop of a mesh using geometry nodes? Technically, yes. Is it? Do you have an example geometry that we can test it with? Because I think it actually might be a bit more complicated than we want it to be. Yeah, I think you might actually have to use a repeat zone, because you would be basically at every junction you would find the vertex of the edge, and then you would find so we're currently on the 0 offset. You would then want to find the edge of index 2 based on that mesh topology edges of vertex. So you'd have to like sort index would be the current index plus 2, and that gets really complicated actually. But don't send me something because I don't want to have to think about that right now. That sounds really complex. Definitely something that we should be able to do. Another example of why node groups are like relatively high level in terms of the amount of stuff in them, but you're creating a system like select an edge loop that is actually extremely low level in terms of your user journey. So there we go. All right. Does random color work? Oh, heck yes. Oh, I'm so glad. Amazing. All right. So now if we go into our, I can't believe that worked. I didn't even put on the, yeah, I didn't even preview that. Let's find which attribute is going to be the side here. The cube, I think, is the second one, so that's probably like 8. Oh no, maybe 9? Maybe 7. There we go. So that's our cube that we can then mask in here. That's a pretty good mask actually. And we will make this a new color, which we could just do with another mix in here. That's the factor. Let's go with purple. Let's go with orange. Coming into there, and then we can also mix this in, or I guess add. Onto that, and we will also do it onto the value, or actually no, let's mix for the value. Sorry, mix for the roughness there. So I'll do this mask as well here. And then we will just, there we go. So now we have our shiny negative booleans. Hey, welcome back. Yeah, developing it is so funny. Making an exploding fireball, sure, no problem. Now select an edge loop. No way, that's too complex. That is actually exactly how it is with geometry nodes. It feels like it should be fairly straightforward, and then it's just like, oh, that's great, that's really complex. Oh, that's interesting. This is a, okay. We have some errors that I'm simply not going to fix. I am sorry, but we're already like over 4 hours in. A little bit of an error down here that we can fix. What happens if we turn off these ads? Does it get significantly worse? Actually, no. Does it get faster? 1852 versus... Yes, it gets considerably slower using those ads. Okay, let's avoid this cleanup because that is crazy to allow it to be that slow. So let's skip it at the beginning. And because it's actually, excuse me, it's not actually giving us the results that we're after anyway. So we will use geometry proximity from points. How do we do this? Based on our join geometry from our proxies, right? And our proxies are just these pieces. And then we can use this basically to delete geometry. Over here. Oh, absolutely tanking. So yeah, let's just delete geometry. Over here. It's a shame because oh, actually no, it is the volume cube doing all the work there. So yeah, let's delete delete that geometry. Oh no. Oh, that's annoying because it's, yeah. Yeah, that's tricky. Maybe just deleting small islands would be enough, like anywhere less than, I don't know. We'd have to find out what the average island size is. And then if you're, maybe that would be a good way of doing it, or an adequate way of doing it. So let's say you've got a bunch of islands and some of them are, or like most of them are very high poly, as these are. You know, if we have a look at our mesh here, we're looking at 90,000 polys, so actually not crazy high, but there we go. So we've got a bunch of little artifacts in here, and obviously each of these islands is quite small relatively. So if I was to take an accumulate field, is that the best way of doing it? Good morning, Josh. How's it going? Or evening for me. Actually, what time is it? 8:30. So we're going to count up here, and we're going to count up per mesh island. So let's grab a mesh island index node, and this is going to give us yeah, so I could do it below a certain area. I was going to do it based like a certain distance from the average island size, but yes, area would work exactly the same. Here we go, volume cube. Oh wait, no, flip faces. There you are. So yeah, like most of these are massive, except for a few that are like 2,000. I want to find the ones which are really small, because some of these should be actually tiny. Yeah, these should be like 20. If I can find them. Actually, we can just turn on attribute types, can't we? Yeah, okay, so these are 46, 28, 20, 12. So these are small, very small, relative to the rest of them. Have I tried Instamat? I have not tried Instamat. What is Instamat? Now we want to find out what the average is. So let's use a statistic node, I guess. Is that right? Sure. Volume to mesh. Having a look at that total value. So we're going to find the mean average, which is 600,000. Is that right? That can't be right. Oh wait, no, because it's decimals. Okay. Yeah, maybe doing the area is actually better. I mean, it works out. It ends up being the same, doesn't it? If it's just based on this. But maybe it's just easier to do the maths because we don't really need to do the statistics. We can just basically say, or we could even do it based on the volume of the bounding box, or like the size of the bounding box. If I'd like take this length, or if I take the length of this, that's the diagonal length of our bounding box. Yes, geometry proximity and accumulate field for sure. So geometry proximity basically samples the distance from the evaluating geometry to whatever is input here. So if I do a grid here, trying to think of what a good way of explaining this would be. Good morning from New Zealand. How's it going? What's my favorite game? Have I played Red Dead Redemption? My favorite game that has a lot of nostalgia for me, but actually I don't think I would enjoy if I played it again, is Monster Hunter Freedom Unite on the PlayStation Portable. I played that game so much, and it was like a very important time for me during my like teenage years, and it was just like, it was a fantastic escape. And then now I play Monster Hunter World a lot, which I feel like is tapping back into that nostalgia. in terms of like moving experiences, I think Dear Esther, which is basically a walking simulator with some poetry. It sounds really rubbish, but it's actually incredible. So yeah, Red Dead Redemption 2 is also incredible. Yes, I have played it and I thought it was fantastic. Some of my friends worked on it. Okay, so geometry proximity. Let's just stop this tree from computing for a second. A thin diagonal streak might avoid a bounding, but and slip through. Oh, because it's thing is, it's still going to be tessellated down to the resolution of the to the resolution of the, oh my god, what's the word I'm looking for? The volume cube. So it's never going to be like a long stretched triangle. It's always going to be subdivided. So it's always going to have points but a low area. So I think, yeah, doing it based on area is probably a good shout, like you said before. Have I played East Shade? I have not. I haven't actually heard of East Shade. Let's take a grid. Where we at? There it is. And I'm going to increase the vertices, and I'm going to turn off wireframe drawing so that we can see what's going on. And I'm going to take geometry proximity from a second mesh. Here we go, which will be smaller. Oh, good heavens. Oh, right, sorry. This mess is caused by all of the attribute text. There we go, great. So if I shrink this down, the distance, these are two grids which exist on the same plane, right? So we can just view it from above and understand, hopefully, what's going on. So we've got two grids. The lower one that is going into my viewer is the one that is doing the evaluating. And what it's doing is it's evaluating the distance. So every single point is evaluating the distance from the faces of that second grid. So you can see that when I change the size of this, it's every point. So where it's 0, it's basically saying I'm in contact, and where it's a higher value, it's literally further away. That value we're looking at is literally the distance. So you can see, like in the viewer, we've got 0.434453, sorry. And that literally means that it is 0.453 meters away from the nearest point of this second grid, or the nearest face. If we do it based on the points of that grid, then we can see that it's actually doing the distance, the nearest distance from any of the points, specifically the points. The source position, or the sample position. So what that's doing is it's basically saying if the grid up here, if it was sampling, so by default this is just the position, right? And it is the position of our sampling grid. If we were to say, oh well, like for example, I could say that the position was going to be just, so if we were to think of transforming our grid like in this axis, so it was only sampling from these points, then that would look like taking the position and multiplying it. Let's just multiply by 111 to begin with, so it's all the same. If I were to reduce my Y scale down to 0, then you can see that we basically have this stretched value. So every point on our grid is evaluating the distance to the nearest point of our second grid based on this algorithm. So the position, just looking at the x-axis really. You could even do this as like a multiply add, and then you can see I can actually transfer this. So it allows you just to have a little bit more control over stuff. And this is super useful if you're stacking things. So like, let's say you do a ray cast to a surface but then you can immediately use that hit position as the sample position for geometry proximity to find the distance from certain points on that surface. So yeah, lots of ways to kind of abuse that. Accumulate field, on the other hand, this is a sum loop. So for every whichever domain you've selected, in this case point, if I take a points node, right now we have 1 point, and if I have a look at my, so we have leading, trailing, and total. So let's say I have 10 points on here, just generating 10 points. If we have a value of 1 and we look at the leading value, then starting from the value, you can see 0. The first one is that value is 1. If I set this to a float, then you can see it's whatever this value is. So if it was like 2.5, then it would start at 2.5. Every other point or every subsequent point that it reaches is going to simply add this value or add whatever value is on that element if you've used a field. So you can see here I'm counting up in 2.5s. The trailing value simply is the same idea, but it starts at 0. So 0 and then the first one, or like 0 is 0 and then 1 is 2.5. And the total is just the sum. So you can see I have 10 points. And so if you total 2.5 times 10, that's what you get. Group ID is basically a way of grouping. So I could say the index greater than some value. So let's say I did this greater than 5, right? Or 4. Now you can see that I've got 0, 1, 2, 3, 4 as a 0, and then 5, 6, 7, 8, 9 as a true, or we can actually read that as a 1. So if I use this as the group ID, and then look at my trailing value, let's set this back to 1, and let's set this to an integer so it's a bit easier to look at. You can see that we've got 0, 1, 2, 3, 4, and then when we start the new group, we start again. So that's how that works, basically. Josh, did it take a while to get used to working with a huge cursor? It actually did, yeah. The thing is, I was recording a course at the time. This was actually my first course, which is procedural texturing with, or procedural materials with Blender. And I think that was recorded in something like 2.92 or 2.91. And yeah, it took me a really long time to do it, and I kept changing. Like I would start recording, and I would make my cursor really big, and then I would change it back afterwards, just because it felt so stupid. And it gets in the way as well. Like you'll hover over something, and I won't be able to read the socket. Like I'll hover over it, and then it's just like I literally cannot see what it's telling me. But yeah, after doing that course, I was so used to it. I probably spent like 20 or 30 hours of like recording course content. But yes, you do eventually get used to it, and I actually can't work without it anymore. So like on my laptop, I've made it massive as well. It's just like a comfort thing. It's like clown shoes. Okay, let's finish this off. Yes, I would definitely work with viewer nodes. That's the thing with debugging, is it's like you actually have a spreadsheet, and as of 4.1, 4.0, 4.1, you also have attribute text. So you can literally look at the viewport and be like, oh, it's a 3. You don't even need the spreadsheet anymore. And also, if you have real geometry, like you've not made it with geometry nodes, and you come in here, let's have a look at our vertices. Is it this? Yeah. So look, if you click this button here, it just says show selected only. I wish it would just highlight the selected, but that's okay. So you can see that I'm selecting literally index 3 and that's its position, or index 1 and that's its position, or I can select all of them. So if you have actual geometry in the spreadsheet and you click this little cursor icon, then it will do it just based on the selected points. So yeah, super useful. What was the last thing we were doing? Oh, right, yeah, just deleting these based on island area. We were going to use island area, weren't we? So accumulate field. Group ID is the island index. Actually, do I need that? Yes, I do, yes. And then we're going to use face area. We're just going to count up face area. So it's not going to be volume calculation. I actually don't know how to do that without yeah, without being a really heavy compute. So face area will do fine just because these are small faces. And we're looking at the totals here. And we're looking at the totals on our flipped faces. You see that some of these are actually really low values. So we've got like 26s here. Let me turn back on that attribute text. Wait, that's not right. There we go. So these are like 0.01, 0.02, whereas this stuff up here is bigger, unreadable. There we go, 26. How does 26 compare to this length value? That length is 14. So I think what I'm interested in is there must be some, or I could even do the volume, couldn't I? I could do the volume of this. If I just multiply x by y by z. And that would give me the volume of the full box. So let's take another separate x, y, z. We're going to do it. This separate x, y, z here is multiplied by our density, so we don't want to use that. But if I literally just multiply these three together, I'm going to turn down my density as well. I want that to run faster. Multiply, multiply, multiply. There we go. So that's big. 563. Oh, but then does that make sense? Because some of these are always going to be, like, you could have two small objects a really long way away from each other. I think it does need to be based on the average volume size, doesn't it? It needs to be like... Sorry, I know I'm jumping around a bunch, so I apologize, but... if I have... Let me try and explain what I'm thinking right now. If I have... So this accumulate field here, this gives us our total volume, sorry, our total area, total surface area per mesh island. This accumulate field gives us an index within each mesh island. So you can see I've got a 0. This accumulate field, if I use the trailing value as the group ID, I wonder if I can do this. I find this stuff really complicated or confusing. And then I'm going to take the total into my accumulate field. Is that what I want? So now every... Oh, maybe that's not what I want. Yeah, this is not what I want. I want to not confuse myself. I just want to find out what the average is, and I'm going to cheat it by using a statistic node. So attribute statistic. There we go. Just so we can wrap this up in reasonably good time. Let's take our total value from the accumulate field. So this is giving us a sum. It summed the area per mesh island. That's all we need to know about this. And we should do this on the face domain. That's better. And then the statistics on the face as well, just because these face areas are calculated per face. So there we go. Now we have the mean value. What's standard deviation and variance? Does anyone actually know? Like, should I be using these? Standard deviation is 39. Away from what? 101. If anybody knows what standard deviation is, let me know, because I might be about to make a mess of myself. Are any of these totals greater than this subtract? Oh, that's the wrong one again. Oh yeah, that's definitely, that doesn't help me. So somewhere between, I don't know if there's a good way of doing this. There probably is, but I'm just going to take a mix between the average and the minimum. So mean is the average, like this, the sum divided by the count. And I'm just going to literally mix between these. How far do I need to go? That's crazy. Deviation amount is around the mean value. I really need to look into this stuff for that. I see that every time I use this node, I see it and I'm like, oh, I wonder if that would be useful to know. Standard deviation is a measure of how spread the data is. So is that something that would be useful here? For example, I have the mean value and I have these big, mostly large meshes. Mostly, but not always. You see that little one down there is still lit. This feels like a very janky way of doing this. I mean, it works, but it doesn't feel very procedural. Like, what I really want to do is basically say, well, most things are within this region, but anything which is in that, like, 99th percentile, delete it, which is sort of not what I've just done, but also sort of what I've done. Either way. What we have now is some balls. Let's turn them into glass, because everyone likes glass. We're going to go into our transmission. We're going to set our weight to be 1. Ooh, we should change our roughness to just to be 0, actually. Actually, we should do our roughness based on these surfaces. So this one should be 1, this one should be 0, and this one should be 1. Something like that. And then we have these metallic surfaces. So for any random data that's normally distributed, you can expect a 99.7% of data points to be within 3 standard deviations above or below the mean. Okay, so the standard deviation value was 31, if I remember correctly. Sorry, 39 it was. So does that mean it's within 39 standard deviations? Very confusing. What about face area instead of volume? So yeah, I did just do it based on face area, not volume. Just because I actually don't really know how to calculate volume in this context. Oh, so just because my values are really high, it just said that they were very highly scattered, which does make sense. There were like some with 60,000 points and some with 20 points. Let's come in here, let's grab our empties and we'll move these up. Get these up on top of here. There we go. And then we've got our objects as well. And I might actually just make these draw as wire. Oh, we've already, yeah, just because that remesh. I wonder if I could actually just decimate that remesh because it's such a low poly object. And I feel like it was actually, it's going to be, yeah, let's do a planar of 5 degrees and then we'll do a collapse as well, just to go back to those edges. Because I feel like that was actually slowing down our... Oh no, slowing things down a bit too much. Okay, definitely not without glitches. Using this Suzanne is really, seems to actually have a lot of trouble. I wonder if it's to do with this. That's interesting. This is one of those things where I just genuinely have no idea how to fix it. Like, it just seems to be... it's just confused. It's just a confused problem. Okay. Turn that back off. Actually, let's grab our cube and we'll just make this a bit more, oops, a bit more choppy. And then I will pull this one in here. And this one is also subtractive. Suzanne is made up of multiple objects, but that's why I remeshed her. So I threw a remesh on just to make her manifold, basically. Oops. Yeah. So should be one continuous mesh now. Hey, Quackers, thank you very much for hanging out. I appreciate the input. This one is subtractive. Let's add another cube up here, just to double check that we can do additive as well. Oh yeah, hell yeah, that worked. And then let's hide these. And let's increase. Oh, it's a shame we don't get like an additive subtractive. I mean, we could do just a mask for subtractive things. That might be one final thing that we want to do. Yeah, I think that would actually be really good. Because we're basically calculating it here. Right? So we know this factor is to ignore adding those colors. So we just need to use this plus the SDF, and that'll just go, let's just see if this works. Wait, is that right? So this is our subtractive, or I'll just call it sub. It's going to be a float on the point domain. Is volume remeshing the only way to get SDFs to work in Blender at the moment? It is, yeah. Yeah, unfortunately, there's no way to draw SDFs without using volume to mesh. Unless you're using a custom tech stack, like something like Conjure SDF using a custom OpenGL drawer. But yeah, for the rest of us. What are we looking at? So this switch is, I feel like I need to, this switch is -1 for, it should just be a 0 or 1, shouldn't it? I'm just trying to think here. Maybe I should actually, yeah, add sub. That's just true or false. But if we make it into a new, we'll add another switch on here. And we might need to switch these around, but I think it should be -1, +1. There we go. And now these are inverting things. Let's take the general SDF. Yeah. Sorry, my brain's running a bit slow. So we're just going to take this minimum value, we're going to multiply it by the output of this switch, which is our additive subtractive information. And then we're going to just plug this onto our sub attribute. And then over here, rather than using these SDFs specifically, which we obviously still have access to, but let's have a look at what sub's going to give us. That That's not what we're after. I could do a rematch of the subdiv plane in front of the camera. Yes, you could do. Also, if you want to, check out CG Matter's latest tutorial on doing exactly that, because that is just a crazy workflow. Okay, this is not quite right. What are we looking for here then? So if I just do that minimum directly, that's also not helping. If we just do this one directly, what's that going to show us? Ooh, that's a lot of color. So it should be the SDF. Oh, the SDF is already... Oh wait, no, that's not right. I feel like we're so close to cracking this, and then we're done, and then we're done. The reason I want this is it's just like, it would be really nice to have that. Maybe I need to actually throw it around as its own SDF. It would just be really nice to have that compute available, just to be able to say, oh, these are all negative cut surfaces, like all of them, if you wanted some specific texture or something. So I'm just going to do what I think might be the solution, which is to add a new input here, which is going to be, I'm just going to call it subtractive because I think I've just been using that language now. We're going to go for a big number, just the same as before. Yeah. And then actually I think somebody did a Mandelbulb SDF thing on Shader Toy, and you can implement that inside a world shader inside geometry. Inside Blender, and that's just that's just, there's something about that. Something about that. Mandelbulbs are these incredible like 3D infinite fractals. You've probably seen them around because they're used quite commonly for like generic fractal visualizations. But yeah, just so interesting, so beautiful. Right, so we have our subtractive one, which is down here. This minimum. What did we do before? Yeah, early EV experiments. So before, oh yeah, we did that switch based on the sign. So it was just collecting. Yeah, so it was just collecting values for these. And now the signs are both this, which is this top one, comes down here. And we need to fix into the top of this, which is going to be this bottom one. Here we go. Is that correct? I hope so. So that's our subtractive. Our subtractive from the start comes into the smooth min as well. And then the output, that smooth min also goes into that. Ooh. Oh, yeah. Okay. I love it when like the thinking you use in the past comes and actually works for you. Let me just make sure these are using the correct smoothing distance, which is going to be group input smoothing plus, because that's where we're joining those booleans together. And that should about do it. We definitely have some errors in here, but I'll take it. I'll take it. So let's come in here. We're going to just limit these values a little bit. And then we're going to make sure that these are coming off the same one. Here we go. Here we go. So now every subtractive value is now just going to be colored automatically. What's the goal right now? No, don't worry. I saw a thing on, I think it was like a Twitter post about like whether you're a primary or a secondary screen streamer. Basically, like whether somebody is watching you directly or they put you on a second screen. Oh my god, I can't speak anymore. A second screen, and I definitely identify as a second stream. You understand what I'm trying to say. I'm like not primary screen material. I'm very much like, you could just take a nap and listen to me in the background. The current thing is the final thing that I wanted to add, which was just having, like, obviously we still have all of our like 3 SDF, like these auto-generated masks, wherever this is, there we go. But I also just wanted to have anywhere that there's this like subtractive boolean, I just want to be able to mask all of that all at once. So we were just adding a little bit of logic just to make sure that we were controlling all of those subtractions at the same time. Just before we finish, let's make sure that Suzanne has horns. I feel like this is an important thing to do. And there we go. Subdivide this. There we go, nice curly horns. And then we will do the same on the other side. And this one actually is going to be clipping through. Oh man, that's not good. Let's do our origin to 3D cursor. There we go. And that's, well, this is really not. There we go. Needs to make it look natural, you know. Okay. Was there something that inspired you to try doing this effect? There was. What was it? Somebody was asking about. Yeah, somebody needs to take responsibility for this, because this has turned into a whole thing. Basically, somebody was asking about using metaballs for controlling distribution inside. Whoa, she looks great. Inside geometry nodes. So they were wanting to basically create like the leaves of a tree or something like that, and have metaballs used basically for the position of things. And obviously my initial response was like, oh well, you can't use metaballs inside geometry nodes. And then I thought about it a little bit more, and then I thought that you could if you just make them. So then to solve his problem, I was just like, oh, this would be much easier if we just had metaballs, if we could just use metaballs. And that's really what happened. So there we have it, folks. This is, I don't know how useful this is, especially with the performance. So as soon as, I wonder if we need to give it the option of limiting itself to not use SDF maths. Is it Inigo Quiles? So there's a guy who does, he has a lot of maths. Yeah, this guy. You might have seen some of his cool projects where he's like built people out of SDFs and things like that. But on his website, he has this distance functions. And you can see that he's basically defined the functions for things like a sphere or a box or a rounded box or a frame. We've got torus, a cap torus, cones, hexagon prisms. Maybe I should add SDFs to ETK. In fact, do you know what? I actually have SDFs in ETK. Not many, but if you have ETK right now, you can go into masks, and in here we've got things like selection prism, and this has an SDF output because it's useful to have it for like selections. If you want to like erode or dilate a selection, it's very useful. This is behaving very slowly because I cranked my density, by the way, so oh, it's going really slow, isn't it? There we go. But you can see here we've got actual SDF outputs. So I might make a pack of SDFs because then it might be more fun to, just because this is really slow doing the mesh stuff. If I remove all of the objects from the mesh stuff, then it's not fast by any means, but it's 300 milliseconds for a relatively dense geometry in here. Like, that's actually pretty good. And then, you know, you can come in and you can move these things, and it's fairly responsive. It's not incredible, but it's okay. Let's I say it's okay. Oh, there we go. That's interesting. Oh, do you know why it's doing? I think we need to just accept, actually, or find a better way of doing this delete. But for now, I'm just going to mute it. Is ETK on Blender Market as well? It is indeed, yes. It's very slightly more expensive on Blender Market just because Blender Market takes a bigger cut. So, yeah, baby's got to eat, you know. So, right. So empty's fairly performant. Mesh is not very performant. Even if I take out Suzanne, I don't think it's going to really speed things up that much. Going for objects. Oh, and you're still getting those errors. Gah. This is not a perfect system. Hopefully, if you're following along at home, then you can find out ways to improve and build upon this so that you don't get all these little islands. There's definitely got to be some way of doing it that works nicely. But yeah, 4.5 seconds, compute without Suzanne, and Suzanne being a fairly heavy mesh, relatively speaking, a few modifiers. Goes up to 10.5 seconds, that's not good. And we do just have a bunch of points. Yeah, some artifacts may happen. Is ETK compatible with Blender 4.0 since it's saying 3.6 is last standard? It is, yeah. Yeah, so you can just use it, and mostly it works. Like, most of the nodes are convenient. Like things like isWire, it's such a simple node. But some of them don't work perfectly just because the nodes have changed or things just need updating, but it does fundamentally work. Yeah, it does fundamentally work. And I'll be updating it as soon as possible. But yeah, this week coming, we've got a 7-part tutorial series coming out on the driving game. And then at the end of April, early May, I've got 4 new procedural modeling courses coming out, aiming for July/August. There'll be a full beginner course, which will hopefully have more more general stuff. So there'll be like a module on maths for proceduralism and a module on like different workflows, like a little bit on procedural modeling, a little bit on UV mapping, just like a smorgasbord basically of picking up different things, which I think will be useful for beginners coming into it. One general exercise, but taught across a series of modules that will hopefully give you a good foundation. So that's mid to late summer, I'm hoping for. Then I'll do an advanced course, and then I'll do the Geometry Nodes Compendium, which will be like a everything geometry nodes as a reference guide. And that's probably going to take us all the way through the year. So that's what I'm expecting. Yeah. I was hoping to do 10 courses this year, but I'm thinking 7 sounds like quite a lot of work still. I think my previous best was 2, so we'll see. All right, I'm going to wrap this up because we've hit over 5 hours and I'm losing my voice. But thanks so much, everybody, for coming. This has been an absolute blast, for me at least. I love doing things like this. I will get this file in its current state uploaded onto Patreon for free. You can download it for free, and it will be linked. I'll just update the link in the description. There's a placeholder there. Yeah, so this will be up in the next 5 minutes. Thanks everybody for hanging out. This is yeah. If you've enjoyed the stream, then leave a comment down below and I'll be sure to start doing these a bit more regularly. Regularly, because yeah, they're really fun for me. Yeah, okay. I'm also really bad at signing off streams, so thank you very much. I hope you've enjoyed yourselves. Hope you learned something, and I'll catch you in another one real soon.